That's it. The little blue bar says we're live. Today is Monday, the 14th of May, 2018. So far, it's an English hangout tonight, but I think Josh from America is going to join us in a bit. But anyway, on the panel today, we have Astral, who lives in Denmark. We have Patricia, UK, and special guest is Dave Marsh. Hello, Dave. Hello, Patricia. Hello, Astral. I'd just like to say this bit about Dave Marsh. I'm really proud of him. He's been one of my longest flat earther friends, and he's a very kind man. He's been a convention speaker this year. He's like a moon map maker. What I mean is he's out there, he captures the moon. He likes capturing it on the Tropic of Cancer, the equator, and Capricorn. He is doing masses of research, and he's just told us that a few places are interested in him on the media. So congratulations, Dave.
Congratulations. Sorry about that. I just nearly shared the link.
You did, Dave. Luckily, I was talking, so no one could see it. Anyway,
sorry about that. For some reasons, the notifications keep coming up on my laptop. I'm just trying to turn them off because I don't want them to come up during the presentation.
Yeah, if you just got the screen ready for everybody. But as I said, I'm so proud of you. And you just before you start, so how was the convention? Because you were one of the main speakers there.
Yeah, it was really, really good. I was quite surprised, really, because I didn't expect as many people to be there as there actually was. But when I come to my presentation on the Saturday, it was full, so it was quite nerve-wracking because I'd never actually been through the presentation. In fact, I'd only just finished the presentation an hour before I went on the stage. It was a little bit rushed towards the end, but I talked to Iru Landucci and he says just go out with a bang. So I tried to make it. So I just went out with a bang.
No one's there while you're speaking.
Yeah, so it was good. I really enjoyed it, and like I said, the response after the convention's been unbelievable. I've had requests to go on ITV, the Jeremy Vine show on BBC. I've spoken to Johnny Vaughan. I did an interview with Shortlist magazine.
Yeah, well done, Dave.
And the good thing about the interview with Shortlist magazine, there's no ridicule in there. It's just a straight interview, and they basically just record. I recorded it over the phone, and they just put down exactly what I said, which was really, really good. So I think I did share it on Facebook. If you see a cat flying in midair, that's the actual picture for the download link. It's got like a cat falling off a table or something like that.
Okay, everybody, what's that on Facebook?
Yes, I shared it on Facebook. I think I shared it in quite a few groups. I think I shared it in your group too, Karen, if I remember rightly.
Right. And it would be really great with these people that are interested in you, Dave, if they were really interested in how the moon really works.
Yeah, well, all I've been doing, I've been tracking the motions of the moon and the speed of the moon. If you start asking me questions about phases and other things, I probably won't be able to give you a positive answer on that because I've been concentrating solely on one aspect of the moon. So, like I say, I do know little bits and bobs, but I've just been concentrating solely on the motions of the moon because that's what I've been doing. I've been tracking the speed of the moon, and as you'll see in a minute, the moon doesn't do what it's supposed to do because according to Kepler's law, the moon's supposed to follow an elliptical orbit, which I'll talk about in a bit, and it's supposed to speed up at its closest point at perigee, then slow down at its slowest point at apogee. But it doesn't seem to follow them rules for some reason, and I'll be showing that. And I've documented the data to show it as well, all backed up by mooncalc and time and date. So the information's there for you to find it. It's just digging it out of the actual information what they supply you.
Anyway, we talked about this in the past a bit. Like no one can do everything, and like when we were meeting people, everybody's a part of this puzzle because you're doing the moon. Some people like the sun. Some people like doing other things. But very much appreciate all the work you do, Dave, because I know that you've done masses with the moon.
Yes, like I've said before, if I can just find one piece of that puzzle, this puzzle, what we're looking into, flat Earth, then I'll be happy. You know what I mean? And if I can pick up some people on the way who believe in what I say, that'd be good too.
So you've got a presentation you'd like to show us?
Yes, I have. This is the presentation what I put together for the convention. It's basically all the data and all the observations I've done over the last 2 years for my Moonrace series videos. I was actually making Moonrace 3, but what I thought I'd do, I thought I'd put it on hold because I'd found some information which I thought would be quite interesting to present at the actual convention. So I saved it. I've still got the video half made on my computer, and I'm just waiting on Dee Dee now to send me the rest of the information and video from the convention, you know, the live feed, so I can add that to my video, because that will save me no end of time, you see, because I'll be able to chop little bits off here and there and add it to the video instead of going through it all again, if you know what I mean. So it hopefully after Dee sends it me, maybe a couple of weeks later, I can get my Moonrace third Moonrace video out, which will be brilliant, because I've been holding back on it for like, well, 6 months now, because I was going to be bringing it out at the beginning of the year.
Is that because you want to do it one more time, so there's absolutely no debate?
No, I just I saved it because like I say, I wanted to present that information at the convention to have something new what people didn't know, because no disrespect to the international conference, there wasn't much I didn't know when people went on stage. There was a couple of things what Iro Landucci presented which I thought, wow, that was good, but other than that, as you know, many flat earthers know quite a lot about the sun, the moon, or the actual flat earth itself, you know what I mean. They're quite well educated in that department, so it's not easy to surprise a flat earther with new information, because they've done their own research themselves.
But then again, you're a bit of a master at what you do, aren't you, Mr. Marsh?
Well, you know what I mean. I've just tried to hone my skills into in one direction, and trying to just to keep on track with the motions of the moon, and that's what I've done. And obviously, when you're doing this kind of observation information, you're always improving on a daily basis. You know, a mistake you made in the last observation, you correct it for the next time you do it. So you're always improving and always learning as you go. You know what I mean? You get to a point where there's many times I've got to a point of thought, why is this? Why is that? And I've had to look it up or find out why that does that or something like that. So there's lots of different things and new techniques and different ways of capturing the moon, which I'll show you from both my Moonrace videos, because I've got the one from March and I've got the one from August, and you'll see the difference in quality from when I actually recorded the moon from March to August. It's, you know what I mean, I'd learned so much about the camera itself as well, using the exposure aperture lock system.
Your new camera, Dave?
No, it's the one I've always had.
I thought you were getting a new one. I wasn't sure. I can't remember now.
Well, they haven't brought a new one out, so I can't get one.
No, I'm at a different camera altogether. Sorry, that was.
I've had it. I bought it not this Christmas, the Christmas before, so I've had it like a year and a bit, like a year and a half. So yeah, same camera.
One, a P900.
No, I've got the Nikon Coolpix B700. It came out after the P900. Yeah.
There you go. So you did have a new camera. Is it that long ago since we talked about the camera? Wow.
Well, just the camera's a little bit. It's a little bit upgraded from the P900. The only difference is it doesn't have the 83 times zoom. It only has a 60 times zoom, which, to be honest, is not that much difference between them. You know what I mean? I've worked alongside a P900 on the Bedford level experiment, and looking through the viewfinders on each camera, there's not a lot of difference when you get past that optical zoom. It's all digital zoom after 60 and 83 times on the cameras, like, so there's not a lot of difference actually. And the good thing about this camera as well, it shoots in ultra HD as well, and it captures images in 20 megapixel, whereas a P900 only shoots in 1080 and caches them in 16 megapixel. So you've got actual improvement on the pictures, and it captures raw images as well, which is good, because that's something what we're missing off the P900. but I wouldn't advise capturing many raw images because each photograph's about 60 meg. So it's quite, it sucks up the memory when you capture them in raw images. I actually caught a few raw images, and I think I sent a few to Mike Helmet when we was looking at the moon phases and why the moon sometimes the dark side's visible and sometimes it's not visible. It's a strange old moon.
Yeah, that's crazy, isn't it? The chocolate chip cookie, you mean?
Yep, that's the one.
In the chat room sometimes a few of the people there still send me cookies for that. And maybe people think, well, is there cookies flying around? And Pearson, she sends me cookies, and sometimes P900 cookies for that reason. But anyway, you really like filming on the equator, Tropic of Capricorn and the Tropic of Cancer, don't you? This is what your presentation is going to be about, where the moon is there. Yeah,
I've always captured the moon in that position because it's the good marker points, if you know what I mean. So, you know what I mean? I can find out where they are. I'll tell you what we'll do. We'll start the presentation now. Yeah, so it should go full screen when I kick it, and you should see the intro to my all my videos. And tell me if you can hear the sound as well.
No sound.
No sound.
No sound. It's playing, but there's no sound.
Yeah, it's not a major problem. I can do it without the sound.
Okay, then I've got it on you, Dave.
Right. Okay, then. So we'll start the presentation. So I'll just make a little disclaimer before I do start the presentation, and that's all the observations and all the readings and everything in this presentation are my own readings and my own personal beliefs. I'm not saying these are the facts. I'm just saying from my observations, I've come to these conclusions. Two things as well I want to say is, first, I'm no Steve Jobs, so presentation skills aren't at the top of my list. Yeah, and another thing, am I a scientist? No, I'm not. Yeah, I'm just a normal person.
You probably are the modern day scientist, aren't you, Dave?
Well, I suppose when you're making observations and you're recording it, I suppose everybody can be a scientist, can't they?
Yeah, so, but you're more real than the rest.
Yeah. So my presentation, Moon Race, the motions of the moon from a flat Earth perspective. Obviously, you've got your globularists who like to do their observations from their perspective, and I've got my own perspective for making observations for the moon. So I'll just tell you a little bit about myself. My name is David Marsh. I'm 46 years old now. Just had my birthday.
Happy birthday!
Another year closer to death.
Oh, Dave, I'm older than you. Shh.
That's one way of putting it. Yeah. So I've been doing research in flat Earth probably about 2.5 years. I think it was around about November 2015 when I first stepped onto the flat Earth, and I've spent the majority of the time observing the moon because I've always been fascinated with the moon, and like I said it before, if I can just concentrate on one aspect of flat Earth and maybe just find one little piece of that puzzle, I'll be happy, and hopefully I can wake up a few people on my journey.
Yes, Dave.
So
I'm one of them.
Yeah. So the history of flat Earth. Yeah. Some people think flat Earth's pretty new, but let me tell you, it goes back hundreds, if not thousands of years. Yeah. In fact, we've been questioning the shape of the Earth since the beginning of time, right back to the early Egyptians, if not before then. The only people who actually thought we lived on a globe was the Greeks. So it's not a psyop. And even in the 6th century, there was a guy called Cosmas. He'd written a book called The Christian Topography, which even in the 6th century, he was debating his fellow monks in regards to the shape of the Earth. They were still talking about the shape of the Earth then, and it's gone right through, even though it did get buried a little bit between the 6th century and the very, very early 1800s, but it for some reason there was an explosion again in the 1800s where you got Carpenter, Rowbotham, Williams, quite a few flat earthers. Lady Blunt was another one, Albert Smith. A lot of flat earthers seemed to come around about the early 1900s, but after World War One, boom, gone again. See, these wars, you know what I mean, they drain you as a nation, and well, you have to start rebuilding after that. And that war just came at the right time, because I think flat Earth was trying to be forced into schools around about that time. And Alex Gleason was actually trying to get his information in the schools back in the day. So flat Earth is not a psyop.
I agree with you. I think that's exactly what the First and Second World War were all about.
Nobody
in
in human history, as far as I know, has thought the world was flat.
Did you hear? Now? Yeah, because I put my microphone inside my ear so you could hear it.
Can't do both. You can't have your earphones in and do the presentation. That's what it is. It's going to your
Yeah, so what I did, I actually fed the microphone through the earphone just for that bit, because I wanted you to hear that. Did you hear that message from Brian Cox then?
Do it again.
Absolutely no basis at all for thinking the world is flat. Nobody in human history, as far as I know, has thought the world was flat.
So that was a message from Brian Cox, and he's saying nobody in history ever believed the world was flat.
Well, that's a lie.
I said, hey, it's nice try, Bri. Yeah, because every single ancient civilization in history believed the earth was flat. From the Egyptians, the Norse, the Hindus, the Incas, the Navajo, the Hebrews. Every single civilization thought the earth was flat, except the Greeks. And that's questionable as well. So, but even though the Greeks thought they lived on a ball, they thought they lived on a stationary ball at the center of the universe. So it was actually a geocentric model in itself. So, flat Earth proof. I just wanted to say, when I'm referring to flat Earth, I'm not referring to the Earth as some kind of a pizza floating in outer space. Yeah, I'm referring to there being no measurable curvature over large bodies of water. A good example of no measurable curvature over large bodies of water was the famous Joshua Nowicki shot taken from the Chicago skyline from Lake Michigan. I think it was about 46 miles the distance, and it should have been God knows how many feet below the horizon, but it shouldn't have been visible. That is a fact. But the interesting thing is on that one, when someone sent Joshua Nowicki's photograph into Fox News, they turned around and said the conditions are right on Lake Michigan for there to be a superior mirage. So they basically turned it into a superior mirage. But Rob Skiba did a little experiment where he actually filmed the Chicago skyline, and he basically powered his boat from basically one end to the other and kept the Chicago skyline in his viewfinder all the time. So clearly it's not a mirage, but you do get a lot of refraction on the lake at the times, depending on the atmospheric conditions, but it shouldn't be available to see. And what you will notice as well on the Chicago skyline, that the horizon line, if I could just get my mouse, is always at the eye level. Regardless how high you go, you always have the horizon at eye level. Even at 121,000 feet, you go to the piggy cam, which wasn't actually a flat Earth proof. It was just a video what was filmed from a high altitude balloon. You'll see that the horizon, or the horizontal eye zone, is always at eye level. Now that wouldn't happen on a globe. The horizon would roll away from you. But as you can see there, clearly the horizon is at eye level. And if you look at the size of some of them clouds down there, I mean, I bet them clouds are actually quite big clouds. There's quite a lot of ground it's covering there, because if you watch the camera carefully, it's not just swinging left and right, it's actually rotating left and right, you know what I mean? So you're actually seeing quite a lot of horizon skyline there. So that's quite interesting. Moving on to images of Earth. All I did here, I basically went onto Google, I typed in images of Earth, I clicked on images, and then I just took a screen snapshot. And that's what you get. There is no proper photographs of Earth, although they do claim the ones captured on Apollo were real, but they look a bit suspect to me. And as you can see, no two images of Earth look alike. Not one. Look, you say you start from the left-hand side here and go on. Every single Earth is different. I know some of these are actual composite images anyway, but these top ones here are supposed to all be real images of Earth, and you can see
They've drastically changed then.
Yeah, not one image looks like the other one. And funny enough, this is the guy who makes the blue marble, Mr. Blue Marble, aka Rob Simon. He's the data analysis for NASA, and he's been quoted in saying how he makes the actual globe is he takes a flat map and he basically wraps it around a ball. So that's how Mr. Blue Marble gets his nice, beautiful looking globe Earth. But
and
all
he still doesn't get it.
Yeah, it is Photoshop because it has to be. That's his own words.
Obviously paying him very nicely.
Yeah, so what are we told? Well, we're told that we live on a globe and we're orbited by a single satellite, which we call the moon. The moon takes 27.3 days to complete its cycle, or one orbit of the Earth. But the moon phases take a little bit longer. They take 29.5 days. Now, the reasons why the phases and the cycle are different is because the cycle is based on what you call the sidereal, which is the stars, which basically says the stars to occupy the same spot the following night. It takes 23 hours, 56 minutes. But the phases are actually based on the sinusoidal day or the solar day, which we all know is 24 hours. Interestingly, there's quite a lot of different cycles on the moon. You've also got what you call a Saracen cycle, which takes something like 18 years. You've also got a cycle which goes from perigee to perigee. That's basically from this point here back to that same point. That cycle takes 27.5 days. So you've got various different cycles on the moon, and to get your head around all these different cycles, it's quite mind-boggling.
And look at the little globe going round and round.
Yeah, what I'm going to do, I'm just going to pause it here. Now, I'm sure many of you have seen a crescent moon at night time. In fact, I see one a few weeks back and took a photograph of it. What is interesting, when you see a crescent moon at night time, if you look at this little moon here, it's still in the path of the sun. So, like one day after a new moon, when you just see a little slithering of a crescent moon, it shouldn't be visible at night time because it's still in the actual light of the sun. So next time you do see a little crescent moon like that, tell yourself that should be impossible according to the heliocentric model, because the moon's still in the path of the sun.
But they don't want us to think. Well, I haven't done the thinking, you've done the thinking, and you've done the researching, but they don't want us as a people to think, do they? That's the point.
No, and that's why you've got the Gregorian calendar, because it's really confusing. It's got 28 days a year, 30 days there, 31 days there, leap year there. You know what I mean? It's all over the place. That's just the confusion. Turn your clocks back here, turn them forward there. It's all to keep you confused, because if you had a basic 28 days and 13 months, it'd be too easy for you to work it out. So they make it very, very difficult for you to work it out.
Mars travels in an elliptical orbit around the Sun at one focus of units. Although he chose to list it first, Kepler only came to this conclusion after figuring out his second law, which says that if you draw a line from the Sun to Mars and wait a fixed amount of time, that line will sweep out a certain area as Mars moves along its orbit. What Kepler noticed was that this area is exactly the same no matter where in the orbit you are. This is often phrased as Kepler's equal area and equal time law, and this law works because Mars
It's a little bit low, Dave.
speeds up the closer it gets to the Sun. So
I don't know if the chat room can hear it.
it's traveling faster than if it's at Aphia point that's farthest away. In the first case, the line connecting Mars to the Sun is very short. But because the planet is moving faster, it covers a lot of distance. In the second case, the line segment is much longer, but Mars also moves more slowly. Either way, the area swept out in a fixed amount of time. Kepler and his contemporaries could see that Mars doesn't move at a constant rate. They didn't know why. This inverse relationship that Kepler proposed between distance from the Sun and orbital velocity could explain the puzzling observations of Mars movements, but only if the orbit is an ellipse. A circular orbit would mean no change in distance from the Sun with time, and thus the velocity would be constant as well. These two statements, that Mars travels in an elliptical orbit and that its speed varies so that the Mars-Sun line sweeps out equal areas in equal time, were generalized to include all planets in 1621, and they constitute Kepler's first and second laws of planetary motion.
Did you hear that okay, or were it too quiet?
Yeah, the very beginning bit we didn't, but we did hear most of that at the end. Yeah.
Well, don't worry too much about it, because I'm going to talk a little bit about Kepler's law now. Interestingly, when they showed that video, they actually debunked themselves by showing you that video, because the first thing what you'll notice on an elliptical orbit, you need two focus points or two foci for an ellipse to work. But you see, they've got the Sun in one focus of the ellipse, but there isn't a second focus point. Now, that should destroy the ellipse without that second focus point, because one single point will make a concentric circle, whereas they're telling us that the elliptical orbit's like slightly off center shape. Yeah, but you need a second focus point for that. And interestingly, after Kepler's law of planetary motion, William Herschel actually set the Sun into motion, because the Sun was actually stationary up until that point, but he actually put the Sun and all the rest of the solar system into motion, which then again absolutely destroyed the ellipse, because instead of getting elliptical orbits, then you got cycloidal orbits, or like spirals or springs. So he basically destroyed the actual ellipse. And not only that, Kepler's law of planetary motion was built up on the back of observations which were recorded by his predecessor, Tycho Brahe. Now, Tycho Brahe made his observations of Mars in the late 1500s. This was before the telescope was actually invented. So all Kepler's laws are built up on observations before the telescope was even invented. I know that they had some clever little gadgets back then, astrolabes and what have you, but compare Tycho Brahe's observations to my observations. I'm using the latest optics camera equipment, and I'm using GPS coordination to make my observations. So yeah, people mock me when they say, "Oh, you're debunking Kepler's law with a camera and a phone app," but I'm backing up all my data with mooncalc and time and date to make sure my readings are accurate. So they can mock, but we'll have the last laugh. Here's an interesting quote from one of our famous guys, Nikola Tesla. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. Now, that is so true, because there is no observation. There's only flat earthers making observations these days. All the rest are just equations. So that's an interesting quote. I'm sure you know who this guy is, Neil deGrasse Tyson. Neil claims that the Earth is a sphere, but it's not a perfect sphere. It's slightly oblate. It's an oblate spheroid. Not only is it oblate, but it's slightly chubbier below the equator. Basically, it's pear-shaped. Now, what I'm going to do, I'm going to just read you a quote out from Zetetic Astronomy from 1904, and it's on page 14. This is straight out of the book. It says, theory first of all makes the Earth to be a globe, then not a perfect globe, but an oblate spheroid, flattened at the poles, then more oblate until it was in danger of becoming so flattened that it would be like a cheese. And passing over minor variations of form, we are finally told that the Earth is pear-shaped, and the ellipsoid has been replaced by an apoid. What shape it may assume next, we cannot tell. It will depend upon the whim or fancy of some astute and speculating scientist. I think that's brilliant. Next, Neil will be telling us that they're shaped like a shiitake mushroom.
Sounds like they're trying to cover every angle.
Yep, it's amazing. Like I say, everything what spewed out of Neil deGrasse Tyson's mouth is just reciting from books. You know what I mean? It's a joke.
Yeah, agree with you on that one.
So my observations. What I did here, I used an app called Alptra, and I just set my compass at 0, well, nearly 0, and I just took a photograph with the app. It takes a little snapshot, and it gives you an azimuth reading and a declination angle. What you can see from that reading there is that the app I'm using, so it's a free app off Android. I think you can get an iOS version called Theodolite as well. I think you have to pay for that one though. But you can see it's pretty accurate. There you can see, look, I've placed it at north, and I've placed the app over it and took a little snapshot to show that the readings I am taking match up with the compass. So all my observations were made using the Nikon Coolpix B700. I always recorded at the same frame rate, which was 60 frames a second, the same zoom, which was about times 50, and from the same location, which was from my back garden in Ripley at the time. So I've always recorded my readings from the same spot. And not only that as well, I always try to catch the moon at my zenith, which was 180 degrees from my location at the time. Now I just want to give you a little bit of a comparison between flat Earth and globe Earth observations. On a flat Earth, one of the first things you'll learn about is perspective. And we learned that when an object, a celestial object, is closer to the observer, it will appear higher in the sky. And when a celestial object appears further away, closer to the horizon, that's how we judge it. That's how I judge it anyway. And I'm sure there's a lot of people out there who think the same. But interestingly, from a globe Earth perspective of the moon, when the moon's high on the Tropic of Cancer, it's not because it's closer to the Earth. It could actually be at apogee at that point in its cycle. It's because of that 5-degree inclination. That's what puts the moon high in the sky in their model. But from a flat Earth perspective, I judge it when the moon's high in the sky. I judge that moon being close to me, and when it's further away on the horizon, it's lower down. So when I was in the hotel at the convention, I come out to the corridor and I thought, wow, that's a long corridor. So I took a photograph of it. And what you'll see is these lights, yeah, they're all the same size. Oh, let me just click back. These lights are all the same size, but it just looks like they're getting smaller and smaller and getting closer to the horizon, just like celestial objects do. The only difference with celestial objects like the moon is it doesn't get smaller as it goes further away. There is a reason for that, and it's called atmospheric lensing. That's why the moon, it actually gets bigger as it gets close to the horizon, because you're looking at the moon through more layers of atmosphere. It will appear bigger on the horizon than it does when it's up high in the sky, because you're looking at it through less layers of atmosphere, if that makes any sense. So my first observation, when the moon was on the Tropic of Cancer, and what you'll see here, the moon is in what I call the northern circuit, and it basically follows the actual stars. It does that all the time, and I took a snapshot on the 6th of March 2017. There you'll see the moon phase, which is a waxing gibbous moon. I also took a snapshot from NASA's Lunar Reconnaissance Orbital platform. Basically, this tells you the position of the moon from a globe Earth perspective. It tells you how close the moon is to the Earth. Obviously, when it's at 28 there, that's 28 Earths away. And when it's at its furthest point, that's 32. So the 28 would be perigee, and the 32 would be apogee. One thing what's quite difficult to get your head around, from a globe Earth perspective, when the moon would actually appear to speed up in the sky, it would be when it's at actual apogee. I know this is difficult to get your head around, but when it's at its slowest point in the cycle, that's when it would appear to speed up on a spinning globe. So just keep that in mind, because that does become quite important later on. But I did run this past my my old pal Chris Monk-Seeley, and he confirmed to me that from a globe perspective, the moon would actually appear to speed up at apogee and slow down at perigee. So that's just keep that in mind. So on the night of the 6th of March, I took a diopter reading, and as you can see, at that point, the moon was at 187 degrees, which is just roundabout south, where I always like to catch the moon at zenith, and it was high in the sky at 56.1 degrees. That's the declination angle. So it is quite high in the sky, as you can see there. I also compared my readings with MoonCalc. You know what I mean? It'd be a bit daft if I pointed my app at the moon. It said it was at 180 degrees, and I went onto MoonCalc, and it said it should have been at 270. There'd be questions being asked. So as you can see, their readings on the time of my observation was 183 and 55 degrees. If I just click back, you'll see mine are 187, 4 degrees out, yeah, and a little bit out on the declination angle. One thing you have to keep in mind, yeah, I'm using a phone app which uses GPS, and you have to calibrate it. So you basically have to swing your arms around like a madman in your garden and do somersaults and all sorts to try and calibrate the actual app. And even if you move like a millimeter, it can be the difference of like 4 or 5 degrees. It's so difficult to get it absolutely spot on, but it can be spot on, and I'll prove that later on.
360 things, don't you, to go around like that?
Yes, yeah, you have to tilt it, you have to swing your arms around, you have to do all sorts to calibrate it. But it is pretty accurate. Like I say, it's not too far out. As you can see, look, 55 and 183 and 56 and 187. So it's fairly in the same direction that I'm pointing, where it should be. That to me tells me that my readings are pretty accurate. So then, 1 week later, when the moon crosses the equator, as you can see, it travels in a fairly straight line when it's on the equator. Interestingly, the moon crosses the equator 26 times a year compared to the sun, which only crosses it twice. Not a lot of people know that. Well, they probably do now, like, but I didn't know that when I first started researching flat Earth. I thought the moon followed a similar path to the sun, but it clearly doesn't. But then again, on the 13th, a week later from my first observation, on the 13th of March 2017, the moon was nearly at full. So I took a little shot of the moon there. And also I took a snapshot from NASA's Lunar Reconnaissance moon phases. Interestingly, the moon's in the night sky there, and on a rare occasion, you can see a full moon in the daytime. That should be impossible in the heliocentric model. Just like an eclipse, when the when the actual moon rises in the daytime, already eclipsed, it's impossible. It should be impossible, but it happens. But they've always got an excuse for it. I can't remember what the name of it is, but it's got a name for it. It's got a really stupid long name. I'll look it up after and find out. So then again, I took another reading on dioptra, 182 degrees facing south again, and you'll notice the declination angle now has dropped down to 39 degrees because the moon's heading south, so it will appear lower on the horizon. A confirmation with mooncalc. Moon azimuth on their website was 178 degrees, and the declination angle was 39. So again, 4 degrees out, which is acceptable in my mind. So I'll take that as being pretty accurate. So my third observation, when the moon, a week later, when the moon's on the Tropic of Capricorn, as you can see now, it's actually below that celestial equator, and it's in what I call the southern circuit. I'll just play that again so you can see it again. I'd just like to thank Jenna Fredo for the first time lapse from the Tropic of Cancer, and my good friend Jose Manuel Silva for this one he captured last year.
Smaller, isn't it, Dave?
Sorry?
Moon looks smaller.
Yes, it obviously with constantly changing atmospheric conditions, the moon will appear different sizes in different positions all the time. I'll pick up on that later on anyway.
Can I just say that Josh, Flat Earth Unity's joined us. He's from California. He might just be listening in, but he's joined the panel. Anyway, carry on, Dave.
Hello, Josh. Welcome, pal. So on my third observation, when the moon was on and around the Tropic of Capricorn, I captured the moon again. There you can see on the 21st of the 3rd, 2017. There you've got the exact same moon phase again. Notice the moon now, obviously it started here at perigee and it's heading towards apogee. I'll just go back and show you that just to give you an idea. There you see, it's heading towards apogee. So I'll just go back to that one. And there you can see it's nearly at apogee now. So when I made my first observation, it was at perigee, and now it's at apogee at its furthest point. Interestingly, this is where the moon should start speeding up in its cycle, but it shouldn't be like just a sharp increase in speed. It should be a varied increase in speed from one point to the next. So it should spend the first half of its cycle speeding up to apogee, and as it passes that point of apogee, it should spend its next point of its cycle slowing down. Even though that's the point where it actually speeds up on the globe, it will appear to slow down from a globe Earth perspective, like I mentioned before. There you see again, I took a reading. What you'll notice this time is I didn't quite catch the moon at south. There's a reason behind that. I've got a full-time job and I start work at 5:30 in the morning. As you'll see there, I left it as long as I could before I shot the moon. It was 5:16 and I then have to pedal 4 miles on my bike to start work at 5:30. So I was trying to rush the moon along to get in position, but I just had to take it as it was for that night, which I don't think it makes a lot of difference. So, but that's the reason why I didn't catch it at south. But you can see I took a mooncalc reading to match up there at 5:16. The reading is 159 azimuth and 15.1 declination angle. 158 azimuth on mine, 15.1. What I did then, I basically raced the moons against each other. So I also color coded them. So the moon, when it was on the equator, I've color coded yellow. The Tropic of Cancer, I've color coded red, and the Tropic of Capricorn, I've actually colored blue. I did actually get the idea from what's his name? The guy who's just messaged me. What's his name?
Stan.
Stan. Yeah, sorry, I forgot his name then. Yeah, I did get the idea. I did get the idea from Stan to color code them because it's a good idea because you can always refer back to it with the colors as well, which also makes it a good reference point. So thanks to Stan for that.
When you first did this, were you actually shocked at the result?
Well, yeah, because obviously I did my first observation. Yeah, and then on my second observation, the moon speeded up. So at the time, I was following the circle AE map model. So I expected the moon to speed up on the Tropic of Capricorn. But what you'll see in a minute is quite interesting. So the fastest one was the moon on the equator. Then the Tropic of Cancer, and then the Tropic of Capricorn. In reality, the moon on the Tropic of Capricorn was just a tad faster than the moon on the Tropic of Cancer. Might sound a little bit confusing, but the reason behind that is, for some reason, even though I shot the moon from the same zoom, the moon appeared smaller that night in that position, and that's why the moon looks slightly smaller. But it was definitely shot from the same zoom, from the same location, which I've showed you from the diopter readings. It was all at the same position, but it did appear slightly smaller, which I did notice. But I went a step further in my next observations. What I'm going to do now, this is an example of how I collated all my data. I didn't just take somebody's numbers for it and use them. I actually went online and actually worked out the meridian passing times between the moon occupying one spot and occupying the spot on the following night. That's how I got my time frame or my marker to actually measure my observations against what the moon's actually doing. So for an example, on the first night on the 6th of March, what I did, I went on to the meridian passing on 6th and 7th of March, and I measured that time frame, and I used that to see if it was matching up with my observations. I have actually got a spreadsheet I'm going to get out in a minute, so I'm going to... Here we go. Can you see that spreadsheet?
Yeah, we can.
That's good. So my first observation on March the 6th, you'll see the moon took 24 hours and 57 minutes to occupy the same spot on the following night. Then you notice a week later, when the moon speeded up on the equator, look at the meridian passing time there. It took 24 hours and 45 minutes to occupy the same spot. So what I'm shooting in reality is matching up with what's happening in reality. So I can say that my observations are pretty accurate, even though it's quite a crude way of recording the speed of the moon, letting it pass your screen on your camera. It definitely works, and I'll show you with my further observations later on in the presentation. And as you can see again, on March 21st, the moon actually slowed down. So that's what got me thinking about the circle model, that if you was on a circle model, wouldn't the moon speed up to cover the more ground? That was my thinking at the time, but I've moved completely away from models now. All I'm going to say is the Earth's flat because there's no measurable curvature over large bodies of water, not because it's a pizza or a Pac-Man or whatever you want it to be.
Yeah, we've kind of taken the same stance, really. We were a square flat Earth group, and now we've decided we don't mind the research like you, but we've kind of stayed away from what shape we are because everybody was arguing about. Well, anyway, carry on, Dave.
Yeah, that's a fair point, and that's the exact same reason why I came away from it, because I was sick to death of just seeing this post, that post, and it drove me crackers, and I just gave up in the end and thought, sorry, I'm just going to stick to the facts. There's no measurable curvature over large bodies of water. which FE Core proved a few weeks back when they measured 40 kilometers, which is 25 miles, over a lake in Holland, the Netherlands. So we'll just stick to the facts for the time being. So as you can see, them readings, there was all from my location, Ripley, UK meridian passing for March 2017. When I first posted my original moon race video, someone says, yeah, but when the moon's further away, it will appear to move slower because of parallax, you know. So when a celestial object is further away and it will appear smaller, it will take longer to actually cross your screen. So he says that's what would happen in reality. So what I did, I took readings from the equator. So I basically went on to time and date, exact same a month, but I took the readings from the equator. And what you find is you get the exact same results. Yeah, even from their perspective, if you did the experiment from the equator, you'd get the same results. There you see on March 6th, 7th, the moon took 24 hours, 57 minutes to occupy the same spot. On the 12th, it speeded up, took 24 hours, 46 minutes. Remember, they're ahead of us, so it would have been actual there on their time, because there's quite a lot of time difference between the equator, especially in Pontianak, Indonesia. And then again, on March 21st, 24 hours, 49 minutes. So that's from 2 locations, but I went even one step further then. I went to a place, well, I didn't go to a place, but I took readings from a place in Ushuaia, which is on the southern tip of Argentina, which is on the exact opposite southern latitude to the UK. And guess what? You get the exact same results again. So it doesn't matter where you are on the plane, the moon should always speed up from that perspective. So that's quite interesting in itself, because that surprised me, that I expected some slight variation in numbers, but they're exactly the same.
What, so you mean everybody in the UK will get the same kind of slow up, speed down, slow up, so it doesn't change? Same in France, same everywhere else? Everywhere
you go, that moon will appear to speed up from their perspective. It doesn't matter where you go on the plane, New Zealand, Australia, it will always speed up, and time and date confirms that, which is very, very, very interesting.
Were you not expecting to see that, Dave?
Well, I was, but I was expecting to see a little bit of variation in the numbers, but they're nearly identical. And I bet if you took the actual times, you know, with the time difference from each location, I bet if you took that into consideration, I bet you'd get the exact same numbers. Because interestingly, I looked at the daylight hours from Ushuaia, and we get 17 hours daylight on our summer solstice on June the 21st, and Ushuaia on December 21st gets the exact same amount of daylight hours on their summer solstice, but on the opposite latitude. So that's quite interesting as well. And this is me hard at work. I just made a little time lapse of me actually collating the data. This is a 2.5 hour time lapse. I was going to put some Benny Hill music in it, but I thought, no, I better not. But this is just to show you that, you know what I mean, I didn't just take somebody else's numbers for granted. I actually worked out the meridian passing data myself. As you can see there.
Yourself.
You see how I sit up with my back, because my back's aching that much. I'm like trying to stretch my back at the same time. Look, that's why I keep sitting up like that. It's quite funny. Well, there I'm gone. And I'm back.
How long did it take you with the actual putting the numbers in and stuff?
It took me ages and ages, because I did it one at a time. I didn't only take readings from observations. I actually took readings for a full year between 2015, December 2015 and November 2016, when the moon was on the tropics and the equator. So I'll show you that in a minute, that graph, when we get to it, because that's interesting itself. So more observations. So we've seen now that when the moon leaves the Tropic of Cancer and heads towards the equator, it speeds up in its cycle. Not only my observations show that, but it's backed up by that meridian passing on time and date. And it clearly shows that when the moon leaves the tropic of leaves the equator and heads towards the Tropic of Capricorn, it slows down in its cycle. What I just want to show you now is it's not a fluke either. If you look at these readings, every single one in yellow there is when the moon heads from the Tropic of Cancer to the equator. And what you'll notice, it always speeds up at that point. Look, 24 hours, 42 minutes, 24 hours, 42 minutes, 24 hours, 43 minutes, 24 hours, 42 minutes, 24 hours, 43 minutes, 24 hours, 42. At that point, every single time. And what I did, I created a graph. And
oh my goodness, it looks a bit like a heartbeat.
exactly. And I was talking to the guy at the convention who actually works in the hospital, and he says that is exactly the same.
Can I say
as
something?
a heartbeat.
I know it's your presentation. I don't want to interrupt you very much, but I've told you this before twice last year when that moon came across on well, people are saying the moon equinoxes, or other people say that there's no such thing. But anyway, we'll call it that because when it hits the Capricorn, Tropic of Capricorn, Cancer, sorry, I saw the moon come in at an angle, and then it went north for an hour, and then it went off, just like that, just like your graph, and it was dragging the stars. I told you this before. Yeah. Anyway, it does a sight like that, just like that. Wow. Yeah. Anyway, carry on.
It's crazy because, like I say, every single one of them points is where it speeds up, but it looks like a heartbeat, and we all know that everything is electrical. If we die, touch wood, what do they use to bring us back to life? Electricity. Everything around us is electric. The sky's electric. Yeah, we generate magnetic fields, and so does the sky. And clearly that the moon is like a pulse. If you put it into a graph, it looks just like a pulse. Like I said, that's a full year's readings on the tropics and the equator.
Wow.
So it just proves you that the moon, when it does speed up on the equator, it's not just a fluke. It happens regular. And that's over a full year. So more observations. So we've seen, I've just said this, but I'll say it again. We've seen the moon now that it speeds up when it leaves the Tropic of Cancer and heads towards the equator, but then it slows down. But what's the moon doing when it actually leaves the Tropic of Capricorn and heads back north to the Tropic of Cancer? Well, let's find out, because I've captured the moon coming back as well to complete the observations. So this time I waited till the moon was on and around the Tropic of Capricorn. As you can see there from my good friend Jose Silva, it's time lapse and moon's below the celestial equator in what I call the southern circuit. Also, I just want to mention that everything I'm referring to in this presentation is celestial phenomena and not terrestrial. Yeah, there is a difference. Yeah, when I'm talking about poles, I'm not talking about geographical poles on a ball Earth. I'm talking about magnetic poles, like on a magnet. So I just wanted to make that pretty clear. I'm talking about celestial phenomena, which is measured in declination, and not terrestrial, which is measured in degrees. So on the 5th of the 8th, which is the 5th of August, 2017, at exactly 11:40, on these observations, I went a step further. I included the times. Not only did I include the times, I've actually took measurements of the actual radius of the moon. Yeah, this is something I'm always improving my observations. Yeah, so this time I went one step further and actually measured the radius of the moon. And as you can see, on the night of the 5th of August, the moon, which was at its furthest point at apogee, measured 371.59 pixels. That's in actual pixels. You can see the little marker at the top there and the little marker at the bottom there, what I used for a measuring tool. As you can see, that's in moon phase, and you can see the moon is there. It's apogee. And remember, when the moon's coming back from apogee to perigee, it should speed up. Interestingly, we've already seen the moon speed up on the equator, haven't we? When it was heading towards apogee, which it shouldn't be doing anyway. Remember, it should speed up then, but it shouldn't speed up on the way back. That's it. Get me wires crossed. I'm sorted now. So just keep an eye on that moon, because that moon's going to be coming back towards perigee, and it should appear to retrograde or slow down in the night sky or the day sky whenever it's visible. As you can see there, 5th of August 2017, same phase. I also took a diopter reading. What you'll see is the moon's low on the Tropic of Capricorn, and it's at 170.
Yes, I put quite a lot of readings in myself, as you well know, compass readings. And you can see, you know, and I was putting them in, I could see at certain times of the month, the moon would be higher in the sky and lower in the sky.
Exactly.
Higher in the sky, lower in the sky.
It takes 2 weeks to go from tropic to tropic. So interestingly, that cycle from tropic to tropic takes 27.5 days, but the actual cycle takes 27.3 days. It's crazy. So the amount of different cycles there is. As you can see again, I took a moon calc reading. My readings are getting slightly more accurate because I'm taking more time and more care to try and make sure my readings match up with mainstream. So you can see there the moon declination angle, 17.3 degrees, and an azimuth reading, which is 178, which is only like 1 degree off south. And there you'll see my reading is 177 and 18 degrees. And then nearly a week later, when the moon was on and around the equator, remember it's coming from the south to the north now. So this is a time lapse actually capturing myself. Yeah, I used to love doing the moon time lapses. They turn out quite nice.
How much time is that when you do the time lapse on?
That's 2.5 hours. You get 10 seconds for 2.5 hours on a time lapse. Depending on your setting or your camera, because I think there's a different setting. You can change the frame rate and it changes the actual overall. I just leave the camera on 1080, 30 frames a second when I'm doing time lapse. But when I'm actually capturing the moon for my moon race videos, I always do it at 1080, 60 frames a second. And that's why I've had to upgrade my computer, because my last computer wouldn't run it at 60 frames a second. It used to be jerky as hell, but this one's nice and smooth now. So as you can see on my second observation, on the 11th of August, the actual radius of the moon is increasing. So that's actually doing what the heliocentric globe model is doing. It's following the right path there. So it's actually getting bigger as it gets closer, which is interesting. So 389 pixels compared to 371. As you can see, it took another snapshot from NASA's lunar reconnaissance platform, and there you see the moon now is on or around the equator, exactly where it is from my perspective. So azimuth reading there, 179 degrees, bang on south, and a declination angle of 33 degrees, which is round about the celestial equator. Confirmation, see the nice straight line the moon travels when it's on the celestial equator. As you'll see there, look, their readings 179.6 and 32 degrees declination angle. Mine's 179 and 33. So I'm getting more accurate. In fact, if you look at that moon there, if I drop that down 1 degree, it'd be absolutely smack bang in the center. It's not easy pointing a camera phone at the moon and getting it smack bang in the middle.
Yeah.
which you probably know yourself.
Yeah.
So my final observation, when the moon was on around the Tropic of Cancer, you'll see again, it's on the opposite side of that celestial equator in what I call the northern circuit. Now, this is interesting because when I measured the moon when it was on the Tropic of Cancer, it actually shrunk. If I go back to my last reading there, what you'll see, 389.5 pixels, 355 pixels. It shrunk. But according to the heliocentric model, it should have been getting bigger. And remember, that was at the exact same location and at the exact same frame rate as the previous shots. Interestingly, the moon was like monochrome that night as well. I could only, I've heard this on a couple of occasions, and a couple of my friends have posted this saying the moon, you can only shoot the moon in black and white. Sometimes you can only shoot the moon in black and white. Yeah, no matter what setting you mess about with on the camera, it always seems to come out monochrome. And this was one of them examples on that night when it appeared monochrome. You can see it there. It's got a slight grey colour to it. The only editing on this picture I've done is by overlaying that measurement tool. That's the only editing I've done on that. That's basically a straight image from my camera onto the computer, and I just overlaid that to measure it. So, but interestingly, it shrunk. It went to 355 pixels. So, as you can see, the moon's getting closer to the globe Earth, so it should appear bigger. Let's just have a helio confirmation on that. So,
does it have the same thing as like the sun? The sun gets smaller and closer, and then it's different when it's higher. It's warmer when it's higher. It's supposedly less. It's cooler when it's lower. Is the moon got the same kind of thing to it then?
Well, interestingly, you should say that. I mentioned before, in fact, I come on your show and did a little presentation about it being impossible to have a full moon in the same hemisphere as the sun. And I think we went through a full year together, and I showed you from time and day that it's impossible to have a full moon in the same hemisphere as the sun. So whenever the full moon's out, yeah, it's always in the winter hemisphere. And that might be one of the reasons why the moon emits cool light on a full moon, because there have been quite a lot of experiments done in regards to measuring the moonlight. Yeah. But going back to the heliocentric model, at perigee, the moon is closer to the Earth and looks slightly larger. Now, I disagree, because when the moon is high at perigee and high on the Tropic of Cancer, it's like up in the sky and it looks tiny because you're looking at it through less layers of atmosphere. So I don't know how they can say that moon will look slightly bigger, because to me the moon looks slightly bigger when it's on the horizon, when you're looking at it through more layers of atmosphere. So I don't agree with that, because like I say, when I shot the moon on that night, it appeared smaller, and it wasn't, obviously according to their model, it's supposed to be closer, but clearly it's small in the sky. And if anybody's seen the moon when it's high on the Tropic of Cancer, you'll see it's right up in the sky and it's tiny. So that was a bit of a interesting point. So again, took a diopter reading, 144 degrees at declination angle 48.1. You can see the moon's getting further and further north, and it's getting higher and higher in the sky. And just a quick reading there, you'll see 144 and a moon altitude or declination angle of 48.6. So again, my moon race for August. As you can see now, when the moon enters frame, it doesn't overexpose, because I'm learning new techniques with the camera, and I'm learning new tricks all the time, and new techniques. I learn as I go, basically. This moon race video is a lot better quality than the other one, a lot more stable, and the moon doesn't overexpose and look horrible as it comes into frame. I use what you call the AE lock feature on the camera. It's got it on the P900 as well. When you press record, you just have to press the little wheel to the right and it locks the exposure and aperture and stops it overexposing. It's good for, especially when if you want to shoot like an occult, you know, when you catch a star going behind the moon, it's brilliant for stuff like that because you can just set it at the right exposure and lock it, and then you can obviously see both the star and the moon in the exact same focus, which would be impossible.
But you did it again, didn't you? Because you wanted to make absolutely sure of what you got the first time.
Yeah, as you can see, the moon on the equator took 5 minutes and 20 seconds to cross my screen. On the Tropic of Capricorn, it took 5 minutes 36. But on the Tropic of Cancer, it seemed to take forever. It took 6 minutes 15 seconds to cross my screen. Look at the time difference there. That's huge. So the results. I need to just go back into my spreadsheet here. So what you will notice here, my first observations were made in August, but my third observation was actually made in September 12. There is a reason for that, and the reason were it was cloudy on the night I should have shot the moon, so I had to wait a full lunar month to get the moon back in the same position so I could shoot it again. It doesn't actually make much difference on the actual readings because I'm still shooting the moon when it's high on the Tropic of Cancer. It's just that it was cloudy and it was actually in daytime when I needed to catch it in August, which was quite disappointing because, you know, when you've waited so long to get the moon in a position and then you go out to shoot the moon and it's cloudy, it's like it's soul destroying.
Annoying.
And that's one reason why I didn't do it with the sun, because if I'd have had to wait for the sun to get in that position, I'd have had to wait quite a long time to get in that exact same position. So as you can see on August the 5th, my reading, the moon took 24 hours and 49 minutes for the meridian passing time on that night for the moon to occupy the same spot. Then when the moon was on the equator, the moon took 24 hours, 48 minutes. So it's speeding up when it's heading towards perigee. Remember, it speeded up when it was heading towards apogee. It can't speed up both directions. It's impossible. According to Kepler's law of planetary motion and its equal area and equal time law, the moon should spend the first half of its cycle speeding up with just a change in speed of around about 6%, and the same when it's going back the opposite direction. It should never speed up going to and from apogee. That completely destroys Kepler's law. It shouldn't do that. It's impossible. And you're probably thinking, yeah, but you could just put any of them readings on the screen yourself. You know what I mean? I've had to type them in there. But what I will show you in a sec gives you the confirmation first. So when the moon was on the Tropic of Capricorn, it took 5 minutes and 36 seconds to cross my screen, and the meridian passing on that night was 24 hours and 49 minutes. When the moon was on the equator, it took less time, so it was speeding up, and it took 5 minutes 20 seconds, and the meridian passing on that night was 24 hours 48 minutes. It's matching up exactly what I'm shooting in reality. And you know, the moon took a long time to cross my screen. It took 6 minutes 15 seconds. Well, look at the meridian passing time on that night, 24 hours and 57 minutes. It's matching up exactly what I'm shooting in reality. And just to confirm this, I took a little snapshot from time and date, and if you see on the 5th there, 23:39 till 12:28, yeah, you measure that time and you get 24 hours and 49 minutes, I think. Yeah. And then on the 11th, 340 to 428 is exactly 24 hours and 48 minutes. So what I'm shooting in reality is backed up by time and date. But interestingly, the moon shouldn't speed up when it's heading towards perigee. Although it speeds up in the globe model, from a globe Earth perspective, it should appear to slow down. So how can it speed up?
But quite often they show us some of the truth and then they cover it over with lies, don't they?
Yeah, they never tell you the meridian passing. I've had to work that out myself. They tell you what time the moon crosses the meridian passing at zenith, and all I did was use their own information to measure the moon to see if it was matching my observations, which I clearly, you can see 100% there. Look, it matches it perfect. When the moon took a long time, the meridian passing was longer. When the moon was shorter, the meridian passing time was slightly shorter. You know what I mean? It's absolutely perfect. And it was confirmed by the meridian passing from time and date for August 2017 when I made my observations. Sorry. So, magnetism versus gravity. This is an interesting quote taken from a book called Ether and Gravitation. It's by a guy called William Hooper. He's a globularist, but interestingly, he wrote in his book, if either of these forces is to be done away with, it must be the mysterious, intangible, unphilosophic attraction of gravitation, which must be replaced by the philosophic and known attraction of electricity, which can be traced to a physical medium, the electromagnetic ether. He absolutely got it, absolutely smack bang on when he said that. Yeah, but then he backpedaled and says, no, it doesn't exist. It's gravity instead. It's mad. He just basically backpedaled at the end of the book and says, no, the ether doesn't exist. It's all gravity. But we know, everybody who's done their research into flat Earth knows that the only true force in nature is magnetism. And we're just going to see a little demonstration now of magnetism at work. There's no sound on this video, so I'll just let it play and I'll just watch it with you. As you can see there, the magnetic field creates its own vortex motion because electromagnetism is the only true measurable force in nature. It's the only force that can be measured. Trains in Japan, they don't run on anti-gravity. They run on magnets. So, my hypothesis. What do I think's going on? These are my own thoughts. Some people probably think I'm absolutely crazy in a minute, but this is
crazy. Appreciate all your research.
This is my hypothesis. Now, this image is always blown me away because the actual bright spot is the moon overexposed, and what it did, it created a lens glare reflection and created an image of the moon. So that light there can create that image of the moon. Now imagine that on an epic scale, with the atmosphere acting like that lens and not the camera itself. Yeah, and that's when I come to the conclusion that the moon is basically a light in the sky and it's some kind of projection. I'm not talking holographic images here. I'm talking like a natural projection. The light in the sky and the atmosphere acts as a giant lens, and it can create an image of the moon, which this image proves, because that doesn't look like the moon to me. Oh.
What does it look like? What do you reckon it? Oh, because it's so bright, you mean?
Yeah, look, how can that create that? It's an optical illusion. What we're seeing out in the sky is an optical illusion. The moon looks like it's probably about 10 miles away. It lights up the clouds locally around it. You know what I mean? It's, if you look at the moon in the daytime, it's the actual image of the moon looks a bit fuzzy and not very clear, but at night time it always looks crisp and sharp, the image, you know what I mean? A bit like a rear projection screen telly. When you're watching in the daytime with the curtains open, you've got a rubbish picture, but you close the curtains and turn the light off and you've got a nice crisp picture. Same with the moon. I think David Weiss did some interesting experiments with the eclipse, where he showed a similar kind of projected light, and he basically cut that light out to make the eclipse. Might be worth having a little look at that video, what he made of last year, which was quite interesting, and I actually related to it to my research. And also that Steve Torrance and Mike Kavanagh come to a pretty similar conclusion in their electromagnetic Earth video, when they said that the orb of the sun is probably a type of projected image. I've come to the same conclusion, and I'm going to stick to my guns on that. So, the electromagnetic ether. We know that matter comes in three forms. You've got your solid, you've got your liquid, and you've also got gaseous as well. But there may be a fourth. Yeah, and that fourth element may be the electromagnetic ether, which is a luminiferous substance for the propagation of light. Basically, it carries all the heavenly bodies according to their frequencies, altitudes, and it carries them around the electromagnetic ether. And the ether is made up of two great vortices, or magnetic fields, and you've got one in the north. There's a time lapse with the camera pointing at Polaris, and you've got one in the south, which actually the stars rotate in the complete opposite direction, and that's from my good friend Paul Kofo, who took the shot facing south from New Zealand. If you put them side by side, there you'll see in the north the stars rotate in a counterclockwise or anti-clockwise motion, and in the south they rotate in a clockwise motion. Some people try and say that's perspective. I said it's two magnetic fields personally.
Like the magnets you were just showing us.
Yep. And just like a magnetic field, you'll have your vortex motion going one way, and on that field you'll have on the opposite pole you'll have your vortex field going the opposite direction. It always goes in the opposite direction.
Ah, see, that's what you see. You see that's not what everybody's rabbiting on about.
Well, like I say, some people will stick to a single pole vortex model. I'm past that. I believe that there's two poles, and remember, I'm talking celestial poles and not geographical poles like on a globe. I'm talking about celestial, not the terrestrial. I'm talking about the sky, not the land. And as you can see there, the moon, when it gets southern declination, it will basically cross the celestial equator, pick up on the ethereal currents in the opposing vortex, and be circling the opposite direction in the southern vortex. And then it will get northern declination, pick up on the northern currents, and be circling in the opposite direction in what I call the northern circuit. If you take a time lapse from around the equator, now if you move that land away, what you would see two vortex or vortices separated by the celestial equator. One goes one direction in the north, and one goes the other direction in the south. This is just to try and give you a visualization of what I believe the moon's doing. So when the moon is in the northern circuit, it will appear to circle, and as it picks up on the ethereal currents in the southern vortex, it will circle in the opposite direction. I know that might sound crazy, but if you go onto moon calc and you go to 70 degrees, what you'll find out is the moon will circumpolar from that observation. It'll be visible for 24 hours. So the moon will spend 2 weeks in the northern circuit in a counterclockwise direction. Then it'll spend the next 2 weeks circling the southern vortex in a clockwise motion. So it's basically going in a figure of 8. And I actually named it the lunar lemur. That's my own word I invented for that. We've heard of the analemma. Well, I actually made one up for the moon, and I call it the lunar lemur. And there you can see a snapshot of the moon over a 27, 28 day period. It clearly makes that figure of 8 pattern. And there's another snapshot over a period, similar kind of figure of 8 pattern. Interestingly, someone said to me, well, if the moon is on the southern circuit from your perspective, how the hell do you see it when you're in the north? But we have this thing called refraction. And what you'll see when a celestial object is perpendicular with the observer, you'll get less refraction. But as the moon, from my perspective, gets southern declination, or from the south gets northern declination, what it will appear to do, it will refract. And as that moon gets further and further away in the south, it will actually project further and further into the north. So it will be visible in the north, and going through quite a few layers of atmosphere, you will get something called refraction. And that's why the image of the moon will project itself into the north from the south. And here's an interesting daytime shot I took of the moon. I took a time lapse in the daytime, and you can see that the moon clearly emits its own light. It's not reflecting sunlight, it's actually emitting its own light. And I'll just click on that again so you can see it again. You can see the moon clearly emitting its own light, not reflecting sunlight. It does actually look like the sun, but trust me, that's the moon. If I took a time lapse with the sun without any filter on the camera, you wouldn't be able to see anything. That was the moon setting. So what is the moon? There's been a lot of questions about the moon over the years. Yeah, when you look at it,
I already said it's a chocolate chip cookie. Anyway, carry on.
Yeah, so I mean, when you look at the moon in the sky, it looks like a rock in the sky. It sometimes looks like a sphere. It sometimes looks like a disc. It looks like it emits. It looks like it reflects. Sometimes it looks solid. Sometimes it looks transparent or translucent. It's been there for a millennia, and we still don't understand what the moon actually does or what it is. We know the word month is derived from the word moon, but still, we still don't know what the moon is. And I think the moon could probably sit there for another 1,000 years, and we might never, ever, ever know what the moon is. But I know one thing it's not, and it's not that. That's supposed to be the Discover Epic satellite, which is 1 million miles from the globe Earth, if you want to believe that bollocks. And as you can see, that's supposed to be the backside of the moon. I don't know what that green line is.
That one's a joke, though, isn't it?
Yeah, I think Rob Simon would probably say it is Photoshop because it has to be. But that is supposed to be a real image of the moon taken from the Discover Epic satellite 1 million miles out. And as I mentioned before, my goal or my agenda is just to find a little piece of that puzzle. If I can maybe contribute one piece of that puzzle towards finding out where we actually live, I'll be happy, and hopefully I can wake a few people up on the way. But that's my goal, just to find one little piece of that puzzle. And hopefully, when I do get my own place, I will start doing some proper research. I can't really do it from me. It's a bit difficult. I'm having to set off an hour early from work. I get home an hour later. So time is a factor. But hopefully when I get settled down, I will be able to start doing some more research. I'm always looking at things and finding out things. So I'm not just sat here doing nothing. That's it. That's my presentation. I hope you enjoyed it.
Yay! Thank you, Dave.
It's my pleasure.
A clap from me. Wow. You kind of moved on rather a lot since you came on.
Yeah, like I say, I'm always improving. You know, every time I've come to a point where my research can't go any further, I've basically, you know what I mean, put my hands up, said yes, I've been wrong, you know what I mean, and moved on and gone in the other direction. So I like I say, I do take on board when people say that's wrong, and I'll say yes, I believe it's wrong too. I need to go in another direction and try and find out more information and more truth.
When you decide to take the screen off, let me know, because I'll take it off you just in case.
Do you want to take it off now then? Because I'm going to go for a quick cigarette. Ready? Are you okay?
Yeah, done it. You probably won't, but just in case, it's on me now.
All right, okay.
That was amazing, Dave. I really liked that presentation.
Absolutely. It was beautiful. Thank you.
My pleasure.
I think when Dave first did he started this moon race, he was actually hoping to prove something, but it proved something different. Well, I'm so glad that we did, because Dave, you've got the hangout up, Dave.
Sorry.
I'm glad I did change it.
How
Just
do I get it off that?
Dave. Put it down. Stop sharing. That's it.
That's it.
Oh, goodness.
Sorry about that. This is the first time I've been online in like about a year, you know. Must be a year at least.
Sister Karen's usually pretty kind. I think she'll let you slide this time.
Right, I'm just going to mute my mic and just go for a quick cigarette, if you don't mind.
Yeah, actually, when you come back, I'm going to say you something that Josh has been doing, but I did put out in the chat room if people want to ask you questions, and people are starting to say thank you for your presentation, Dave. That was really amazing. I thought it was a really good presentation. Thanks.
Like I say, if you want to ask any questions, I'll be back in 5 minutes and they can ask any question they want.
Okay.
All right, back in 5.
Okay.
Miss Karen.
Yeah, Josh, I was going to get you maybe just to explain a little bit about how small the sun really is.
Yeah. We'll talk. I don't have no problem talking about that at all. I definitely wanted to ask a few questions too, but while he's gone, we can talk about the what he showed, the Luna Lemma, the sun one, the Analemma, the sun. You could take a picture of the sun at 2 o'clock every day for a year and layer them on top of each other, and it'll make a beautiful infinity symbol in the sky. They say that the moon does the same thing, though I imagine it might be a little iffy, because as you notice what he just said right there, is like the moon moves. It's almost like erratic. You can calculate it and follow it and track it, but it doesn't move in the same.
You know what it kind of reminds me of? You know when we were little, we used to have those bead counters on the rails. And you used to be able to put the beads up and whatever they were. Yeah. Well, it's a bit like the sun starts this end and it goes up and then it goes down. And so does the moon, but the moon's going up, down, up, down, up, down, up, down, up, 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 down, up, down, up. This thing is doing lots of different things.
Remember, I think it was like 8 weeks ago we were talking, and I told you how we were outside at like 3 a.m, me, Huey, and another guy who's in New Jersey. Huey's in Atlanta, Georgia, the other guy's in Jersey, and I'm in California. We're all looking at the same moon, just a little bit further, a little more daylight. You know, like they have the same moon in their sky, and it just moved a little bit further up into the sky and a little more daylight. You know, and um, now it's not coming out. It went from being out in the daytime to now it comes out real early in the morning again, like it did 8 weeks ago. I'm starting to catch on to its little cycles, and I don't know. I like it. It's really interesting how we can actually, you know, calculate it. I can calculate it within 5 to 20 minutes. That's not like that. I mean, yeah, that's kind of a big amount of time, but that's really kind of accurate too.
It is. I think it's always different when you start looking at it yourself, isn't it? I mean, obviously we've got people in the chat room that do that. You've got, when you're looking at it yourself, like for instance, Flat Earth Dude, he's got a telescope, hasn't he? When you start,
it's just, sorry for cutting you off, Miss Karen, but it's exactly like, you know, when we're children and we explore our bodies and we learn who we are and we play with our hair and we, you know, fiddle with our ears and we explore ourselves. Well, we should be exploring everything with that same wonderment and that same, you know, open mind and acceptance. But society makes it to where it's not so. They nip it in the bud real early.
Most things are no. They're just no.
Yep, exactly. They'll even tell you that it's bad to explore and learn your own body, for instance. Like now, it's nowadays, I don't know about over there, but here in America, it's become more to, it's especially important to talk to your children about those things and let them know that all is natural as far as your body goes, and don't be afraid, and, you know, all this and that. But, you know, but what that really comes down to is actually our world outside of us as well. We must explore and not take what people say and learn for ourselves. Watch, discern, take from it what you gain, take from it value, leave the garbage behind. You know, I mean, that's what you do. You know, when we eat a chicken, we don't eat the feathers. Sadly,
I
we
think
kill
you've
that
probably
chicken.
changed your mind a little bit, though, haven't you, Josh? Because you've been monitoring things yourself, so you only start like really thinking about things. It's okay to say, "Oh, well, I watched this video. Oh, someone told me this." But when you start looking at things yourself, it changes everything.
Absolutely. Absolutely. And you know, the funny thing is Santos is the reason I even heard of the analema. So, you know, this was before the flat earth or any of that. And, well, he got me into that, you know, and little things that people say that have a big impact on me, you know, it's got me to this point. But exactly like you said, it's all about going out on my own. I could have just took what everyone said and been like, yeah, this and that, and regurgitated yet again, like I do with everything else throughout my life. But it's time to change. How can we change everything if we don't change everything?
Yeah, that's about right, Josh. We need to think differently, don't we? But Dave's back now.
Dave.
Can we just, I know that I've asked you, I'm going to ask you to talk to Dave in a minute about what you've been doing, Josh. But did you have any questions about his presentation?
Nothing really questions about his presentation, more a question about the stars that you guys see over there. Do we see any of the same constellations? I'm in California. I see the Big Dipper when I look to the north, and it's about, if I was to like salute Hitler, it would be that like at that trajectory, you know, the Big Dipper, and it makes a circle through the sky. I see Scorpius. I see at the moment the luminaries I see are Jupiter, Venus.
Same. Venus is still out now. It's 11 o'clock at night, and Venus is still visible at nighttime, which is impossible in the heliocentric model because it's on the sun.
Absolutely. Supposed to be the morning star, right?
Yeah, it's there now. I've just seen it outside. You've got Jupiter in the opposite sky, high in the sky. Then you've got Venus just on the horizon there in the.
You and me both. That's beautiful. We can correlate that on two different sides Oh, that's a beautiful thing. But it's I'm getting it wrong. I'm thinking that it was supposed to be Australia that sees completely different constellations. But do you guys see the same constellations I see at night? Is that what the theory is supposed to be according to them? Sorry.
Yes, but I think you will see more of these stars on and around the equator area, because I believe you're further south than us. We're at 55 degrees. I think, I don't know where you are.
I want to say 34.
Yeah, 34. There you go. So you will probably be able to see. You may be still be able to see Sirius, whereas we can't quite see Sirius now. It's gone. I bet you can still see it from your point of view.
The strange thing is, I grew up in Memphis, Tennessee, which is about 2,500 miles to the east of me, and I saw Polaris every night growing up. Here in the desert, where there is no light pollution, I don't see Polaris.
Is it dead
And
faint?
I have planispheres. I have things that show me the direction to look. It's not the brightest star in the sky.
Well, if you look at the Big Dipper, if you look at the saucepan side of it, if you just follow that star in a perfectly straight line, it should take you straight to Polaris.
Awesome. Okay. Okay.
Yeah, it's like a frying pan, isn't it? It's like what the end of the angle on the saucepan. Just follow that straight up, and it goes straight to Polaris.
That's beautiful. I appreciate it. What do you feel? Do you feel there's a correlation with Polaris and the North Pole? And then I'll let Miss Karen take it back. Excuse me for overthrowing it.
Yes, because clearly it's directly above the North Pole. Perfectly. I mean, it's about 61. I think it's about 61 degrees from here. I think I recorded it at 61 degrees in the sky. And my friend David Colkin in Alaska, I think he got it at 70 something degrees. I can't remember exactly the readings, but obviously the further north it goes, it's appearing higher and higher in the sky. So
that's pretty awesome.
Clearly, the further you get to the North Pole, it's getting higher and higher. And I would imagine if you stood on the North Pole and you looked directly up, it would be directly above your head.
At the 12 o'clock position. Yes, sir. That makes sense. That's beautiful. That's really cool that your friend records it at a higher elevation, if you will, or whatever, trajectory. That is beautiful.
Yeah, but you have to take into consideration the southern stars as well, because Paul Kofo, when he points his camera south, he gets the exact same star trails, but going in the opposite direction on a different set of constellations. So, and he can shoot that night after night after night.
Yes, sir. And that would make sense if you think about it as a disc. All right, I'm not one to say things are a disc or they're what they aren't. But if you put something in the center of that and two objects on the opposite sides at 6 o'clock and 12 o'clock, what they look at from their south is not going to be the same south, because they're all looking. The north will be the same, but their south is different. Their east is different. Their directions are slightly askewed, and it correlates with the model they give us. And they don't. But when you bring that argument up, it gets twisted into a different direction. All right, I'm done bothering. I'll let Miss Karen have it back.
Yeah, interestingly, some people say it's just. I think they do a demonstration where they show you like a magnet, and they put it over a map, and it basically makes two kind of like star trail patterns. But I'll just stick to the being two vortices in the sky, or two magnetic fields, one in the north and one in the south. Like I say, I'm not referring to geographical poles. I'm talking about celestial poles. And
yes, sir.
Clearly, from my research and my observations, that there is two, and it's separated by a celestial equator. So, is there any questions then?
Yeah, there is a question in the chat room for you from Lady Onyx. She says, "How long has Dave been researching this, and what woke him up to it? The sun and the moon."
My research.
Sun and moon.
My research started in about. I first woke up in about November 2015. I was watching. I did about 2.5 years research on the fake moon landings, and then I moved on to the ISS. And then all these videos started popping up, flat Earth this, flat Earth that, and I went through every video what was available at the time. Like I was watching like about 6 hours worth of videos a night. I was staying up till stupid o'clock going through them, and I think I eventually watched just about every video come out at the time. But then, I mean, you go on to YouTube now, and there's millions of videos, thousands of videos. You just can't keep up with it. In fact, I hadn't sat down and watched a full video on YouTube in a long time. So it's a shame, really, because there's just too many videos to watch, and you know that you're probably missing something good out there. But yeah, it was about I woke up around about November 2015. I did my first flat Earth video in May 2016 when I got my camera. I got a P610 camera and I shot my first time-lapse of Polaris, and I called it Flat Earth, This is Polaris or something like that. And that was my first video, and that was back in May 2016. So all my videos started from then, and then I've just basically observing the moon. I had that big debate with Darren Nesbitt in regards to the circle and the square model, and that's how I derived the moon race videos. And it's just gone from there, and I've just basically evolved. And that's what my next video will be called. Dee Dee's just sent me a message saying she'll be receiving all the footage from the convention, so I can incorporate that into my video, what I've been working on for the last 6 months. And hopefully I can get the video out in a few weeks, because that will save me no end of time, because I can chop and change bits out of the presentation, add it to my video, and save me doing voiceover on the video and all sorts. So that's good.
Yeah, but it was nice hearing you explain it all on a hangout as well. That was really nice. You kind of changed things and moved along rather a lot. So yeah,
it's not easy to remember. I did it all. You know what I mean? I've done it all by mind. I haven't got anything here in front of me with any paper or anything like that. I've just did it all off the back of my head, like. So I did mess up a little bit on one bit, but never mind.
Well, hear it or not, it doesn't matter, Dave. You did really well. Trouble About lives in Australia. She thinks she sees Polaris.
I'm not sure you can see Polaris from Australia. I know you can see it just below the equator, but I'm not sure about you can see it from there. I'm gonna say you probably can't see it from there. We definitely can't see the crux from here. I know that. So.
I have to say, though, Dave, even though it's amazing and people will have understood it, this word you're using in there, maybe, obviously people said thank you so much for the presentation, but there might not be lots of questions because we're not as equipped with the words as you already.
Well, like I say, you know, sometimes I've had to make up new words for certain things, like Luna Lima. I made that word up myself because there wasn't a word for it. I actually searched the word and it didn't come up with anything. So I'm claiming that word. That's my word now.
Dave's Luna Lima.
Yes, sir. It was described to me as they both were called Analema. The solar and lunar was both the moon Analema.
Yeah, the moon's Analema, so I renamed it Luna Lima.
I love it.
I have to say,
that's how we take control. Sorry, Miss Karen, didn't mean to step over.
Sorry, darling.
No worries. I was just saying that's how we regain control. That's all.
Yeah. It is strange how you do see things. I can't say what it quite means, because it could mean that Australia's in another day and they're lying about that. But on one of our hangouts, we kind of proved that there's no way the convex map worked, because we had Trouble About in Australia. She was about 3 o'clock in the afternoon. It was about 6:37, whatever it was, 8 o'clock in the morning for us because we're so many hours behind. And America, where Josh is, it was still 11:30 the day before. So that came on a hangout. I don't understand why they couldn't actually have done that bit themselves, really.
Yeah, I did a moon sync with Robert Jackson in Tasmania, Australia, and according to the Google, he was 10,700 miles away. He was shooting the moon the following day in the daytime, in the morning, and I was capturing the same moon at the night time the night before. So, you know what I mean? It was both synced to the second as well, and I posted that on Facebook. I called it the impossible moon sync because it was impossible.
Point is Australia cannot be anywhere near America. It was 3 o'clock in the afternoon. America was still 11:30 at night.
Yeah,
the day before.
It's probably on the, like I say, it's probably on the same southern southern latitude as somewhere in South America, but obviously it's not in that position.
We're sort of on the same latitude as Germany, isn't it? The longitude, we're the same. It's the latitude that changes. Is that right? Is it that way around?
Well, the cross is the latitude. Yeah, so we would be probably on the same latitude as Germany. Like Ushuaia is on the exact opposite latitude as the UK. So that's at 55 degrees south, where 55 degrees north. Interestingly, Ushuaia is the furthest place you can go in the south, whereas here you can go to Svalbard in Norway, which is right up at 70 degrees. Yet we can only go 55, 56 degrees south. When you get to like 65 degrees there, you hit Antarctica. So that's quite interesting to know.
It's the same sort of talk. Josh is here and he's there at the moment. Josh was showing us something. Josh, do you want to tell Dave what you were doing?
Yeah, all right, we hear that the sun is so many miles away and it's so many times bigger than the earth, or so many times bigger than the moon. Well, I took a welding hood, a real cheap one that I found, and broke the lens out of it, and started looking at the sun, and the sun is the same size as the moon at both sunrise, sunset, and midday. It's large like the moon is when the moon is at moonrise, and same as moonset. The sun is large at sunrise and sunset, and it all is appearing the same size. I almost believe that they are the same distance from us, and they are not at all what we think they are. Not a ball of fire, not none of that. But they're actually electromagnetic, dielectric, diamagnetic. All they would definitely have to be dualistic, whatever they are, because everything in this world that we know of is dualistic. But yeah. So basically, I just been looking at the sun, and I kind of track the sun as well, the length of the days, and trying to find the true equinox, because they give us the equinox off by a good minute. This year it was off by 6 days. And yeah, that's pretty much it. Sorry, if you'd like to build, please do.
No, yeah, it's interesting because like the sun is like the electric, the positive side of it, and the moon is like the dielectric, the negative side of it. Whereas the sunlight is quite preserving, and they reckon the moonlight is like putrefying, and they reckon that the moon controls the tides. But if it was a dielectric object in the sky, then maybe it would affect the actual inductive or conductive salt water in the seas, and may affect the tide. So it could be related to that as well. It's definitely not a gravity what's pulling on the oceans. That is a certain.
The moon's light to me is more than just petrifying, because I dabbled in mycology for about 4 years. I grew several types of mushrooms, legal and illegal, and they grow. Even if they're not in the moonlight, they grow at nighttime and night hours. And you have them covered up under a bed, or in a closet, or, in an area where it gets minimal light, because they don't require light to grow in the same sense that plants do. And yeah, I noticed that I marked them and started taking pictures and started, calculating it, and they grow under moonlight. They don't grow, they grow during nighttime hours. They don't grow during daytime hours. They don't, all that they do occurs in the night, and the opposite of what our normal, what feeds us. It doesn't feed them in the same way. Excuse me.
That's interesting. Yeah, very interesting. Yes, I've never dabbled in that side of psychedelic drugs, but
even just growing oyster mushrooms. I don't know if you're a person who enjoys mushrooms as far as eating them, but
yeah,
all mushrooms grow basically the same way, and it's interesting to watch their life cycle, because it's a unique one. Mycelium, which is like a spider's web almost, and it can be the largest mycelium they ever found was larger than the Amazon rainforest. One organism that large.
wow.
And mycelium, Paul Stamets, let me not say they, Paul Stamets, which is a mycologist, he postulates that all life came from fungus.
Cool. It's interesting. It is really interesting.
Sorry to take that out of left field like that, but I just wanted to add the moon's light is definitely something more than just what we think, what we've been told. You know, they will tell us that it is putrefying and this and that, but I found it to also be cleansing. I don't know if you moon gaze. I don't know if you're one to just like stare and ground yourself and, you know, shoes off. Just, I don't know. I'm one of those weirdos, bud.
Yeah, I know that the reckon that sun gazing. I might actually try and do a bit of moon gazing because I need to start doing a bit more filming of the moon. So it might be an opportunity to take my shoes off, dig my feet into the ground, and do a bit of moon gazing.
Absolutely. The sun is also not bad if you can catch it in the sunrise and sunset.
Yeah,
they're not damaging in any way. But I'm a hard-headed, and I looked directly at the eclipse for about 20 minutes while the eclipse was occurring, and I was blind for about 3 days. And so I definitely don't recommend anyone stare at the eclipse. But one brother brought up that it's possible that that's what they speak of in the old days when they say that everyone was blind for 3 days during the eclipses. They say that the Mayans no light for 3 days. What could have been them going blind for 3 days from staring at it? I don't know, but I know that I experienced it and it was no fun. I was scared.
Yeah. David Weiss said he stared at the eclipse as well, but he said he felt brilliant afterwards. He said he felt fantastic, like days after the eclipse. So I don't know how you felt
mentally, and everything else. Like it was a beautiful sight. So like basically what happened is the eclipse was burnt into my eyes for 3 days. So the size of the sun, like staring at somebody welding or staring at some sort of like electro spark.
I think they call it archive, don't they? Something.
Yeah, and it boy, it was something. I was scared, y'all. I swear, the third morning I woke up with my eyes still like that. I was like, oh, it's gonna be forever, y'all. It's gonna be. I'm gonna have a dot in my eye forever like this.
Wow. Karen, before I shoot, because I've got to get up for work early in the morning. Is any more questions what anybody wants to ask for I shoot? Because I need to get start getting ready for bed light.
She's MIA.
It's all right. I couldn't unmute myself. Just to clarify, so the sun is electric and the moon is magnetical. Yeah, is that it?
Well, some people say that the sun is electric and the moon is dielectric. Like I say, I haven't really got that far in my research because I've been basically monitoring the motions of the moon. So, but I'm sure if you invite Chris Monk Seeley on, I'm sure he can give you a lot of good information on that side of the sun.
We've probably got it on our videos anyway from when he was on before.
Because he knows his stuff on that side of it. I'm only just scratching the surface of electromagnetism. You know what I mean? It's a very, very, very big area to start researching, and
I would say it's almost mystical.
Yeah, like I say, when you're referring to electromagnetic ether, it's on the verge of being more supernatural than actually,
So I remember you saying this before. Like, if you had to explain it to someone, there is some supernatural thing going on here.
Yeah. Every model, what they've ever brought out, from Ptolemy's system to the heliocentric model, it always needs some kind of supernatural phenomena to make it work. The square map needs a Pac-Man. The globe needs a magical force called gravity to stick the water on it when it's spinning around. You know what I mean? There's always some kind of supernatural force what needs to take place for each model to work. And I know that the Pac-Man model did get a lot of ridicule, and I even got asked about it on the Johnny Vaughan show. But I weren't going there. I was just going to stick to my guns and say, you know what, pal, there's no measurable curvature over large bodies of water, and that's all I'm sticking to. So,
I love it, man. That's good enough for me.
Yep.
But we have to, isn't it? Like, we wanted to do a quiz and we wanted to put all these flat earth questions in, and me and Patricia, we just couldn't do it because in the old days you said, how far away is the sun? How far is the moon? All these things which none of us can answer anymore.
No, I mean, you just can't answer it. I mean, the moon looks like it's about 10 miles away.
Yeah.
If you take Tycho crater and you zoom in on that,
even less.
It'd be impossible to see it.
If it's in the clouds, then it's only feet above our heads.
Yeah, like I say,
it lights
up the clouds locally.
What's so funny is that he said Tycho crater, and our brother Dread, as you've been streaming, posted a video about the Tycho crater debunking their whole little their distance from the moon from here. Well, y'all, anyone who's looked from a distance knows that you can't see very far. It doesn't matter the atmosphere, whatever little argument you want to put, you can only see so far.
Yeah.
Even though something has light on it, you can have a person with a damn laser beam pointed at your eye. If you're so far away, it won't register.
Well, we know we can see a laser from 40 kilometers away because the FE core team proved that over Lake Ilja in Holland, where they basically shone the laser from.
Yeah, we can only see for 3 to 4 miles. How come you could actually see that laser? So what was happening there?
It's just the concentration of the light beam, isn't it? You know what I mean? So I presume you're probably best asking them the question because I've only seen.
This is one of those lasers that was visible from the side, though, right? Like you can see this laser. You can see the path of this laser, right? Like it's one of those type lasers, if I'm not mistaken. Like,
well, you can see the lights on the Earth from the ISS, can't you? So.
Oh, come on. that little balloon up in the sky that they've been lying about for a long time.
I've tried to zoom in on it, and every time I try to catch that thing, it's just too fast. It's just you can't keep up with it. You know, it goes across the sky.
Man. It's by design so that no one with a prying eye could catch on to it.
Exactly.
Like, you have to. What was that? Those couple videos that have people believing that a person was able to calculate it and catch the video of it.
Yeah.
Come on. Like it's the same video on both people's video, but they shade it differently so you won't think so.
Yes, that one they reckon they caught on the eclipse. They reckon they caught the ISS passing the sun during the eclipse. That was completely debunked. That was. I think Crow 777 debunked that as well as Mike Helmet, and I did a little post on it as well, saying it was impossible because they had the phases slightly wrong from one location to the next, so it got completely debunked. But you know, they just like to keep feeding you this rubbish all the time to try and keep the model going or keep you believing in the globe model.
Globe going, got to keep that globe going at all costs. You just mentioned Crow 777 there. Flat Earth Dude had a couple of questions for you, Dave. He thought, what do you think about the lunar wave? And the second part is, what do you think space is?
Well, I don't think that space is anything because what I think that above us is the electromagnetic ether, and all the stars and luminaries are just lights carried in that vortex field. Yeah, and as in regards to the lunar wave, I mean, I've seen it from Crow 777. I've also seen Cass Crane capture it as well because I've got it on my lunar page on Facebook, and there is definitely some kind of reset thing what goes on there, and it only actually affects the actual image of the moon. It doesn't actually affect, if you look at the camera footage, it doesn't affect the actual screen itself. You know what I mean? It's only the moon what seems to have that line going resetting up it. But it is interesting, and it's been captured by quite a few people now on. Quite a few different people on a number of occasions. So what it is, I ain't got a clue what it is. You're probably best asking.
Have you seen halos around the moon before?
Yeah, lots of times. Yeah, I've actually caught a few as well. Yeah.
Here in the desert, we catch them often whenever the humidity pops up. About a month or two ago, we caught a double halo, and it was amazing. Miss Karen has seen me catch a halo around the sun.
Mm-hmm.
what I was gonna ask is, damn it skipped me while I asked about those halos. Excuse me. I'm gonna step away.
Oh gosh. I had a question as well. Oh gosh, mine's. Wait a minute. Let me just think for a second.
Oh, I got it. The lunar wave.
Cool.
The Dread, the person you've been exposed that I was talking about. He showed some video he shot, and it showed he caught one of the lunar waves as well. But in the desert where I'm at, where some nights when I see the moon as a crescent, it has the heat mirage to it. Do you know what I speak on? You know how you look down a street on a sunny day and you see like it looks like liquid.
Yeah. You call it heat wave.
Yeah, the moon. Only the lit part is doing that, and it's doing it like it's beautiful. But I don't think cameras will pick it up the way my eye picks it up. I just don't think it will.
I've never seen that here because we've got quite dense atmospheric conditions in the north. You know where we are. It's quite the air carries a lot of moisture, so we do see a lot of like big moons on the horizon and big suns on the horizon. Like I suppose in the desert you probably don't get as much moisture as we get in the north because it's quite a wet and horrible place here sometimes.
Yes, sir. I've heard. And you don't get much sunlight or starlight or almost any light. Like it's just cloudy all the time there. Yeah.
Yeah, but we do get 18 hours of daylight on the summer solstice.
Yeah, we get some things. We just don't get a lot of others.
Yeah,
I want to ask a question, Dave. Dave, you know when I put out your little video, I did cut it down a bit because obviously it was just explaining that you were coming on. But when you did that star following the moon and it goes through the moon and comes out the other side.
Oh, the occult of Aldebaran.
Yeah, which is on Dave's channel, his channel is in the link to this post. There was a bit where your camera kind of wobbled a little bit and you could see that the moon and that star were together as if it was a hologram.
Yeah, it's strange. Yeah, because the star will just follow the exact same. When the camera wobbles, the star will wobble. You'd think it'd be like a parallaxing where the moon would wobble and the star wouldn't, but no, they both wobble at the same time. Yeah, it's quite difficult to catch a star going behind the moon, and I'm happy to have actually caught that.
Behind it or through it?
It goes behind it. Always goes behind it. It never goes in front of it. Yeah. So let me make that clear. You can't see stars through the shadow part of the moon. Yeah, they always appear after the shadow. So even if you've got an half moon, that star won't appear out until it's past the shadow bit. Yeah, you can't see stars through the moon. Let's just make that clear.
To add to that, Aldebaran means the follower.
Yeah, and it follows the moon on a regular basis. So keep your eye out. If you ever want to catch a star going behind the moon, it's always going to be Aldebaran. Or if you're very, very lucky, you may actually catch Jupiter. But that is a very, very rare.
And it was an orb with a center in it on my iPhone. I couldn't believe it.
Yes, I caught another star, but it was unidentified because when I opened up Stellarium, I caught this little object. I posted on Facebook about a year and a half ago. I caught a little star, exactly the same as like Aldebaran, but very tiny and very faint. Because I'd overexposed the moon, it didn't show up till I overexposed it, and I see this little star. But when I clicked on Stellarium and clicked on stars around the moon, there wasn't any. So that was an unidentified one. That one. So that was interesting.
That's awesome.
Can I ask you another question then as well? If you say that the moon, it doesn't really matter where you are on this plane, as it's going up and down, the different heights is the same. Is this the same with the stars then?
I would say so. Yeah. You got to remember the heights do change on the moon. Obviously, from when the moon's on the Tropic of Capricorn, from here, it will appear to me on about 15 degrees off the horizon. But from someone in the south, it may appear on the equator. It'll be 90 degrees above the head. So it will the altitudes will vary.
But I did say, didn't I?
the
That
speed of
heart-
the moon won't change at all. If it speeds up from my perspective when it's on the equator, if you could jump to the equator and record the moon from then, I would imagine that it would speed up from their perspective and from the furthest point south, like approved on time and date by taking the readings from them locations. They always matched up. They're exactly the same. Like I said, there is sometimes like a minute difference, but you have to remember the time difference. Yeah, there could be 6 or 7 hours time difference between them. If you could match the time differences up, I guarantee them times would be absolutely exactly the same.
I agree with you. I think what we see when we think we see what we see is all due to perspective. We just don't understand the perspective of the moon. We don't understand the perspective of the sun.
We don't understand what they're
that's why
doing.
we
Said,
can't.
I watched that moon drag the stars for an hour and then sort of draw them
Yes,
off, and
ma'am.
then wasn't that they weren't moving, but the moon was moving faster and it just went off west, just like the heartbeat thing. That's the only way I could describe it, like Dave's just said, how the other things work. So what is all this, Dave?
Yeah,
Why
like I
are
said,
we here, Dave? Why are we here?
we're in a big optical illusion. Everything around us, like light, you know what I mean, atmosphere.
I can roll with that.
it-
I love that you said that, Dave.
It
Thank
all
you so much for
creates
saying
your
that.
own personal perspective bubble and gives you all your own unique perspective on things. To try
I'm
and put
so
it into
sorry for
words.
running over you right there, but
No,
thank
it's
you
all right.
so much for saying that. That's exactly, I'm so glad I'm not alone there. I think that me, you, and even if Crow won't exactly say what he thinks, I think that's exactly what he thinks as well. That's the best way to sum it up. You can't catch it because you don't understand the illusion, just like a magician,
And I
just
don't,
like watching a magician sleight a hand.
and I don't think, like I say, we could probably observe we've been observing the stars now for millennia, yeah, and I don't think we know any more now today than we knew when Ptolemy was looking at the stars in the 2nd century Greece. You know what I mean? They had just the same amount of information there than we've got now. Nothing's changed
They
at all.
might do with those big observatories, those big ones, but they're not telling us.
No,
They all need to go to prison, those people, for lying to us.
I don't think they can see any more than what we can see, to tell the truth. Yeah,
I think that he's right, Miss Karen. You know, I told you I'm trying to build my own telescope. And as I'm looking into it, even if you have a 50-inch telescope, it doesn't see much more than a 20-inch. 20 inches is where it seems to top off, 20, 25 inches. I'm starting to think that because, see, they wouldn't let me in the Hollywood Observatory. They would let us take a tour. But I asked, what does it cost to, like, you know, look at, just to take a 5-minute look out of the eye? You know, I don't even care if I get to move anything. Just let me look out of it, see what it sees.
They'll never let you look.
No, they said people have been on the waiting list for 10 years and don't even get an hour.
Yeah.
They probably come away
and
and
you know,
they'll
that's
never
with donations, y'all.
again after that. That's what they see.
Absolutely.
Imagine trying to get a 10-minute slot on the Lucifer camera, what they got at the Vatican.
Yeah, man. And you know, that's supposed to be the best one, they say, right? The thing about these, and Crow pointed it out best, once you start getting into these extremely expensive telescopes, they start becoming digital. Yeah. And once something becomes digital, it's a construct, as Crow will put it. There's a lie there. It's covering up something, adding to something, manipulating it so that you get what you want.
You can manipulate digital imagery, whereas the optical image is a lot harder to obviously to mess about with.
It's silly because like I said, I'm trying to build my own. I messed around and made a Fresnel lens that will, no lie, it will burn the sandstone in the desert and make a little drip of lava pour out of it. I set it up with 5 2x4s and a couple screws so that I can tilt it to catch the sunlight. And there's a lot that they don't tell us, is all I'm gonna say. They're hiding a whole lot.
Cool. I'll be back in 10 seconds. I'm just going to nip to the toilet and have a quick cigarette, but I'll be back in a minute, yeah?
Yeah, because I've got another question for you.
Okay. Hold that thought.
Okay.
Rather like this Dave guy. It's good stuff. Good stuff, Miss Karen. So
Oh,
sorry
Dave's
if I'm
been a friend of mine for a
stumbling.
long
This
time.
so
He's just
sorry if
been
I'm jumping on anyone. The
that's
latency is
all
just
right,
catching
darling.
me.
He's just been busy and had some personal things in his life, and then after that he had to get ready because he was in the convention here. He was one of the speakers. But Dave is one of the people who's actually
Ah, he's a flat Earth brother, huh? That's what I like to hear, Miss Karen.
made his own presentation, his own experiments. So that's amazing.
Oh,
He's been like doing it
you know,
for 2 years, and you know those races, those moon races, they're on this hangout for, further back. You know, and he wants to do
yeah.
another one as well.
Ah, that's good stuff. I'm so glad to hear that. That's really, really good.
And he's
I
not
heard
in.
our brother Martin had a presentation. I want to say Dave Murphy gave one. I don't know. I would like to see good quality videos of these, but that's the only issue at the moment is you can't catch good quality videos of them.
You know, shall I let you into a? Well, it's not a secret, but because I haven't got that far yet. But it looks like Mr. Murphy will be on Sun and Moon on Monday. Mr. Dave Murphy
That's good stuff. That's always good.
coming on for a little bit, and he also was a speaker at the convention as well.
Yeah, that's what I had heard. I heard it was Dave Murphy, Martin Leakey. I've never heard of Daryl Nesbitt, whoever that was.
Darren Nesbitt, yeah.
All around pretty good. Like I can't imagine it would have been bad speaking. Like the one here in America was a clown show, in my opinion, last year.
Yeah, well, it has to sort of try and fit for everyone that's going, I suppose, doesn't it? So they did the best that they could with everything, you know, because you know maybe they do it differently next year. I don't know, but I just want to say that he's not here right now, so I can say it because he's a very modest person. Is Dave? Through his convention presentation, he's now getting people wanting to interview him on the media.
That's pretty cool. I'd definitely take into it. You know, I think people shy away from it for no good reason. I think at the very least, you should do it just to see and prove to everyone that we already know they're going to manipulate it and make us all sound like lunatics, you know, like, which is okay to me because I love the moon. So being a lunatic is just fine with me.
Yeah, it's a sort of strange place to be, isn't it? Because 10 years ago, oh wow, look, there's the shuttle going up. Oh wow, look at that globe. Wow, isn't that amazing? And you know, like you'd have been like that, but when you wake up, you can't help it, and you just see it for what it is. But he like,
oh yeah, 20 years old, I was listening to the Theory of Everything by Stephen Hawking on audiobook. The other little Quantum Universe by Stephen Hawking.
going to Mars.
The Physics of the Impossible by Michio Kaku. I was just absorbing and regurgitating all that garbage.
Yeah, it's bad, isn't it? And the people that are doing this research, because he said that I'm not a scientist, but he kind of is, because there are no people doing what he's doing. I mean, there are some people doing experiments, not saying there isn't, but I'm just saying it's because of people like Dave, who's actually spent a whole year doing that experiment, and he's still going to 2 years probably actually, because he had the conception and he's always been taking pictures, and he likes using the compass readings and that, and it does show you the tilt of the moon in the sky when you have those apps, because people don't realize that one night it's this low and then the next night it could be much higher. People don't even realize that, but Dave likes capturing that bit on his
inspirational
compass reading.
I love those photographs of the moon with the analema. It just looks awesome. Great poster that I'd make.
Yeah, it's cool, isn't it? Yeah, it's quite strange because like I say, I think the moon is actually moving in like a figure of 8, and interestingly, it in the north it rises from our left and it passes over to the right, but in the south it rises from the right and passes over to the left. And when the moon's high on the Tropic of Capricorn, from their perspective, it rises south of them and it sets south of them. When it's high on the north, it rises north of us and sets north of us. So it basically goes around in like a circle, and it does it from both.
Can I ask you something? How does that quite work when, you know, I've been like here, and 1 minute say I have this view of east, right? So we've got south there and north at the top. Well, sometimes the moon will come up in the middle of my like window, and then the next day it comes up really north, and the next day it comes south. So how does that work with the Analema thing then?
Because when the moon's high on the Tropic of Cancer, it'll rise further north each day as it gets southern declination.
Yeah, but sometimes it's only there for a day or two, and then it comes back. Then it's lower.
Yeah, remember, it only takes 14 days to get from tropic to tropic, and then it's on its way back again. So, you know what I mean? It does like appear like it jumps around all over the place, but it doesn't get southern or northern declination in equal amounts of degrees as well. Some days it'll jump like 10 degrees, some days it'll jump 6 degrees, some days it'll jump 4 degrees. There's not like a pattern to it, like every 4 degrees it'll jump, you know what I mean? It's jumping all over the place when it's jumping, and it's
Yeah,
it's
the sun. They jump all over the place. I tried to explain it. This is either one. They can come in slow, go out fast, come in fast, go out slow, come in slow, go out fast, come in fast, go out slow, come in high, come in low. This thing is not in the same place at all.
Yeah, and like I say, with the speed of the moon, it doesn't fit Kepler's law of planetary motion, because, like I say, you should only see a very slight increase in speed, and then a very slow decrease in speed, and it's only like a change within 6% according to the heliocentric model. But as you've seen, the moon will actually speed up within 7 days of its cycle, so it'll go from like taking 24 hours and 57 minutes, so within 6 or 7 days it's taking 24 hours and 40 minutes to get to the same position in the night sky. So it's jumping up in within 6 or 7 days of its cycle, instead of having that gradual increase in speed over the 13 and a half days, then a gradual decrease in speed. It's like boom, jumps up, jumps down, then stays at relatively the same speed. So it's all over the place.
Yes, and I only know this because I looked at it myself. I'm not as good as you, Dave, the camera, the whole thing, but I know that the moon and the sun move up and down the sky and so forth. And I told you I put loads of compass readings in, so I know that it goes up and down in varying through the month. But there is one question from Flat Earth Dude again. I think you kind of answered this, but how far away do you think the moon is then?
No further than 10 miles, because I think that image is projected in the sky about probably 10 miles away. But if you try to jump 10 miles, it would always be 10 miles back, you know what I mean? It's like an optical illusion. It's always stuck there in the sky. If you're on a train and you go past, it'll just hang there with you. It won't be like disappearing away from you. It'll basically follow you all the way. Same when the moon rises over the ocean, you'll just have a perfectly line. The line will always go towards your feet, no matter if you jump up 10 miles up the coast, they'll have a line to their feet. It's an optical illusion, you know what I mean? It just hangs there in the sky. I believe it's probably the image of the moon is possibly 10 miles away. Interesting, when I took off the plane to go to America, when the moon was in the sky, as I went up, it basically rolled over and it looked like a flat disc. It was strange, like the moon just looked like a flat disc in the sky. As I
say something. I took a little bit of footage of NASA and I put it on one of my videos, and it was the same thing. They showed us that it was a disc that went over.
That's what I did when I took off in the airplane, because the moon was there, and I thought, oh, this is interesting. It's on the same side as I'm taking off, and it looked like a disc had basically rolled over as I got above. It was strange.
Anyway, Josh has left, and he said he's got to go because his children had come home. But he said thank you very much. I know that really you want to end because you've got to go to bed because you're getting up early and you've got to do that cycling. Just before you go, Astral, Patricia, is there anything you'd like to ask Dave? Because you've been very quiet today.
Wakey, Patricia.
Dave, that's funny coming from you, because you went for a nap and you slept in. I woke you up because I rang you.
Yeah, I heard bzz, 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 bzz. That's all I could hear. I thought, whoa, Then I looked at my time. I was like, wow, it's nearly 8 o'clock. Oh,
Yeah,
9
you obviously
o'clock, 9 o'clock, went it? Yeah. Yes,
needed your power nap.
I tried to do everything before I had an hour's sleep. So I had to nip into Ripley, and then I had to pedal all the way back to Morton, make something to eat, tidy the house. And I thought I'll have an hour's kip, and then I'll be nice and fresh, because I didn't want to do the presentation when I was half asleep, because I've been up since 4:30 this morning. And I would have slept right through if you hadn't woke me up.
I'm glad I did. I was thinking, answer the phone, Dave. Answer the phone. Patricia came back then. Patricia, would you like to say something?
Yeah, I just wanted to say I don't quite understand the work that you're doing, because I'm not a big moon sort of fan. I do want to do my own sort of work, but I think what you're doing is fantastic. And one day I might need to pick your brains and stuff. So well done. That was really, really good.
Yeah, well,
Thank you.
What I'm trying to do, I'm trying to build up all my observations, informations on my Facebook lunar cosmology research page. Everything I've done, I've tried to put it on there. What I am doing now, a lot of the stuff is shared to there. I'm actually removing the shared link and actually posting it as a permanent fixture on the actual site. So hopefully, eventually, when I get some bandwidth and some data and some Wi-Fi, I'll be able to start documenting everything what I'm doing. So I've got something to look back on. You know what I mean? Then you can basically trace my research from the beginning, from when I did my first the moon job video, to moon roll perspective, to moon race 2, hopefully moon race evolution when it comes out, which will be incorporated with the data what I've collected now, and all the footage from the convention, which I'll chop and add to the video, and hopefully make another video out of it, so I can get moon race 3 video, or moon race evolution, because even though I don't believe in evolution, I do believe in the evolution of progress, and that's what I'm doing. I'm progressing, and I'm learning as I go, and I'm trying to improve all the time. So that's what I've tried to do in all my research. Learn as I go, as I like to say. If I don't know
what
something,
I like about you, Dave, is that also you're open enough that as far as you get, you may have to change your mind, or you may want to change your mind. I love it. And another really nice thing about you is you're so upbeat and so positive. It's been actually a pleasure to have you on today. And I've missed you, Dave.
Yes, I know. I think this is the first time I've been on in what must be at least eight months.
6 months or something?
6 months, yeah. Like I say, I didn't do anything for 3 months. I've from about January till beginning of April, I didn't do anything. I basically just went to work, come home, and then obviously when I got the new computer, I could start putting my presentation together. I put my presentation together in 3 weeks, so it was quite rushed. In fact, like I say, I didn't finish till an hour before I actually went on the stage at the convention. So I actually blagged the end of it, because I didn't have an ending. And Hero says, just go out with a big bang. So that's what I tried to do. And they actually put that in the paper about me saying about we'll probably never know what the moon is for 1,000 years. That was something I just made up at the end of the presentation. I just basically found a picture on the computer of the moon, stuck it on there, and says, yeah.
It's a bit like, I don't think it's a bit like, as well as we won't be able to handle the truth. That's why.
Well, yeah, but it's funny, because like, out of all the presentation, what I've spent hours and hours, that was just an image I just stuck in there just to fill the end bit up, and that's the bit they mentioned in the papers. Like,
also, you've got a new icon. I like your new icon.
Have I? I can't see it. Is it just
but there's you dangling the moon in cartoon form?
Oh yeah, that's. I must thank Can of Art. It was a few days before my birthday, and he says, I've got a birthday present for you. And next minute, I got an email come through, and I had this cartoon character. So that was cool. I've got my own little cartoon character.
You've got your own cartoon character now, Dave. Yay!
And I used it in the presentation as well, so that was cool.
Yeah, just want to check. Astral, are you there? Astral, Flat Earth, calling Astral.
Yes.
Astral. Yeah, is there any
Please go
questions
ahead.
you'd like to ask Dave, Astral?
Oh, yeah.
Or
Actually, I was
comments?
thinking that you have all these numbers and charts and stuff. Do you have it like in a kind of a visual form, if you understand what I mean? It can be translated, can't it? Relatively simply.
Well, like I say, when I built that spreadsheet up, I must thank Robert Scott from FE Core for building that spreadsheet for me, because he actually built the spreadsheet and I've just built on top of it. But I did try and put a visualization on by putting that graph on there. When you see the basic heartbeat, that's me visualizing the moon. Yeah, and I see it as like a electric pulse, it actually creates a pulse. You know what I mean? When you take all the data from the moon and pump it into a spreadsheet and build a graph from it, it comes out as an ECG reading, which was quite interesting. So that's the only visual side of it I can actually give, if you know what I mean.
Yeah. But it was good.
Yeah,
Nice presentation, man. Very informative. You know, I mean, we've seen a few things before. Obviously, we've been in this flat Earth and what have you for quite some time, but it's always nice to see, you know, from your perspective, if you know what I mean.
Yeah, like I say, and that's why when I went to the convention, I wanted to present something that people hadn't seen before. You know what I mean? Something like we could go to these conventions and say, my name is David Marsh, I've been a flat earther for this long, blah 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 blah. But I wanted to try and present something where people will go, wow, you know what? He's actually doing the proper research and actually presenting results. You know what I mean? Because people laugh at me when we say guy has debunked Kepler's law of planetary motion with a camera and a phone app, but clearly the moon's not doing what it's supposed to be doing according to Kepler's law. Because if you look at the equal area and equal time law, which is the second law, the moon's not sticking to that equal area and equal time. It's all over the place.
Do you know what's really annoying as well, Dave? Well, I'm really pleased that you've done it, but you needed the camera, so that was money, and after that, it's cost you your time. And what have they done? They've used millions of pounds and dollars to do nothing.
Exactly, and you know what I mean. I've always, I've never asked for a penny, ever. I've always said to myself, the truth should be free, and I would never ever ask anybody for a penny. Everything I've bought for Flat Earth, you know what I mean. I've spent thousands on books, thousands of pounds on books. I've got like 50 Flat Earth books, some like really rare books where there's like limited prints and what have you. And you know what I mean. It's all been money out of my pocket, what I've earned. So I would never ever ask anybody for a penny towards my research. I'd rather just fund myself and do the research myself.
Well, you never know. You know, like there was the Bedford test. There was like a Dave Marsh test.
Mm-hmm.
At this rate, though, with these radio shows or whatever, are you going to do any of them, Dave?
Well, I did a podcast. I can't remember the name of the guy. It's called. Is it called Nick McGarrison? The Nick McGarrison podcast. It's on my Facebook page. You have to look it up. Interesting. He's got a triangle and an eye for his icon, and I was like, oh my god! When I clicked on the actual icon, all I could see with this triangle and an eye, I was like, oh no, I'm going to get ripped apart for that. Somebody did comment on it saying, oh, that's a bit strange, isn't it? A triangle with an eye. But like I say, I just did the podcast over the phone, and it's available. It's on my page. You'll probably see the all-seeing eye, so just click on that and you'll.
Dave Marsh on Facebook.
Yeah. I've done like I say, I've done that podcast. I did an interview with Shortlist magazine, and I also was on the Johnny Vaughan Radio X show a few weeks back.
Woohoo! People are listening to you, Dave. I'm
yeah,
really pleased.
Johnny Vaughan tried to take the piss out of me.
I've known you long enough now. I've met Dave, and yeah, that was good. Actually meeting you. So yeah, it's always good when you meet some of the people who you're talking to. Yeah, and you are a nice man, Dave.
Dave,
but anyway,
how did who did you say, Johnny Vaughan? How did he try and take the piss out of you?
Well, he he interviewed me in between a record, so we had about 3 minutes to do the interview, and I just tried to make sure I stuck to the facts. But he wanted to know about the Pac-Man model. So he was really interested in the Pac-Man model, so he tried to get me to talk about that, but I weren't having none of it. I says, look, as far as I know, yeah, the Earth's flat because there's no measurable curvature over large bodies of water, and I'm sticking to that. I started talking about the moon landings, and he started talking about him. Oh, I've met Buzz Aldrin. Yeah, he's a great guy. Why would he lie to me? So, but if in this day and age you should still believe after the footage what they've got now of the Apollo missions, there's something seriously wrong with you, and you need to take off the glasses and open your eyes, because if you can zoom in on that lunar module, it's made of curtain poles, paper mache, and duct tape. It's ridiculous. I actually did a nice little meme where I found an Ains manual for the Apollo 11 lunar module, and I put on it, it'll take more than a Ains manual to repair this pile of junk.
Do you think that they were expecting us to be so sort of, were they thinking of 20, 50, 60 years time when they did all that?
Probably not. You know what I mean? You know what I mean?
I don't think they planned on the internet being what the internet has become.
I mean, they reckon they've lost all the footage now, don't they? All the moon actual data and all that. But interestingly, when they said they've lost it, it's not like a little box in a corner with a few little reels.
It's massive.
It's actually like a warehouse full of data and them big old reels they used to have in the olden days. You know what I mean? There's like about 15 ton of data what's gone missing. You know what I mean? It's not like a box that's been shoved in the corner in one of NASA warehouses. It's
not on a memory stick, is it?
Yeah, it's not on a memory stick. It's like a full warehouse worth of data and information.
Yeah, but where do we go? The thing is, where do you go to complain about? Excuse me, I want to know why the moon and stuff's been deleted. They had to delete it because it never existed.
Exactly.
Mind you, only need a car now, don't you, Dave?
Yes. Yeah, I could probably do with a car, but like I say, I'll stick to my bike. It keeps me fit.
Anyway, I know that you want to go to sleep shortly, but can we just say goodbye off air? We will also end this hangout. Thank you to everybody in the chat room. Loads of people writing away and liking your presentation and so forth. But thank you to everybody in the chat room. Thank you to Josh, to Astral, to Patricia, and thank you very much, Dave. I really enjoyed that.
Thank you. It was a pleasure, and I'm glad you got to see my presentation.
Yay, hey. Anyway, so it's good night from us. We're back tomorrow. See everybody tomorrow.
Bye.
Bye. Love you all.